Across the silent, unimaginable gulfs of space, our questions travel at the speed of light, seeking a whisper of recognition. We have always been a species that looks to the horizon, and now that horizon is a tapestry of distant suns. Within this cosmic ocean, we search for something impossibly rare, something that mirrors the cradle of our own existence. The quest is not for any world, but for a very particular kind of world, a sibling to our own blue marble. We are searching for a second Earth, a place where the conditions for life might once again find a perfect, gentle balance. This is the story of that search, and of a single point of light that holds an extraordinary, world-changing promise. To find another Earth, we must first understand what makes our own so profoundly special in the cold darkness of space. It begins with a star, a source of stable, consistent energy that bathes its system in life-giving warmth. Not too hot and not too cold, a planet must exist in a narrow, orbital ribbon known as the Habitable Zone. This is the realm where liquid water, the very solvent of life as we know it, can persist on a planet's surface. Our telescopes, great eyes staring into the void, are designed to hunt for these subtle clues from trillions of miles away. They do not see oceans and continents directly, but instead watch for the faintest dip in a star's ancient, unwavering light. This fleeting shadow, a planet passing in front of its sun, is the first whisper that a new world has been found. For decades, we have cataloged these worlds, thousands of them, each a unique story of cosmic formation and circumstance. Most are violent gas giants or scorched rock worlds, far too hostile for the delicate chemistry of life to take hold. But among the data, nestled in the quiet hum of our machines, a different kind of signal has begun to emerge. The signal speaks of a world roughly the size of Earth, orbiting a calm and steady star within that gentle habitable zone. It is a candidate so compelling, so tantalizingly close to the ideal, that it has become a focus of intense observation. This planet, a potential second Earth, represents the culmination of a search that is as old as human consciousness itself. It is a testament to our relentless curiosity, our innate desire to know if we are, in fact, alone in the universe. Before we journey to this world in our imagination, we must appreciate the sheer scale of the cosmos in which it hides. The light from its parent star has traveled for years, even decades, to reach our telescopes and tell its silent story. Each photon is a messenger from another solar system, carrying with it the secrets of a potentially habitable world. We are learning to read this light, to decipher its codes for atmosphere, for water, and perhaps even for life. The existence of this planet suggests that the ingredients for Earth-like worlds might be common throughout our galaxy. It transforms the question from if other Earths exist to how many and how far away they might be. This single discovery reframes our place in the universe, suggesting we are part of a much grander, creative process. The planet orbits a star much dimmer and redder than our own sun, which would create a dramatically different environment. The sky on this world would not be blue, but perhaps a perpetual, hazy twilight of orange, crimson, and gold. Photosynthesis, if it exists, would have evolved to capture these lower energy photons, painting vegetation in shades of black and deep purple. Because it orbits so close to its dim star, the planet is likely tidally locked, with one side in permanent daylight. Another hemisphere would be locked in eternal night, a realm of unending cold beneath a canopy of unfamiliar stars. Life, if it exists, would cling to the terminator, the twilight zone between these two extreme and permanent states. Here, in this sliver of perpetual dawn or dusk, the temperatures could be mild enough for liquid water to flow. Mighty winds would whip from the hot side to the cold, creating weather patterns unlike anything we experience on Earth. These are not just fanciful speculations. They are the calculated possibilities born from the data we have so carefully gathered. We are standing at a profound threshold, peering through a keyhole at a world that could redefine the future of humanity. This world is no longer just a catalog number. It has become a destination, a focal point for our hopes. It asks us to consider what it would mean to be a multi-planetary species, to have a second cradle for civilization. The journey would be immense, a multi-generational voyage through the silent, unforgiving vacuum of interstellar space. but the very existence of such a world provides a powerful, almost spiritual, motivation to one day make that journey. It reminds us that our own world is a finite and precious system, a singular garden in a vast cosmic desert. The search for other Earths is therefore also a journey into appreciating our own, a way of seeing home from afar. The instruments of the future, like the James Webb Space Telescope, will analyze this planet's atmosphere with incredible precision. We will hunt for the chemical signatures of water vapor, methane, and oxygen, the telltale biosignatures of a living world. Finding these gases would be the single most profound discovery in the history of science, confirming we are not alone. So let us begin our journey, allowing our minds to drift across the light years to this beacon of possibility. We will explore every known detail and every reasoned speculation about this planet that could one day be our second home. Relax your mind and prepare to witness the unveiling of a world that was, until recently, hidden in the stellar depths. This is the story of humanity's potential future, written in the faint, ancient light of a distant, alien sun. The genesis of our search for a second Earth begins not in the sky, but in a simple, almost childlike question: are we alone? This query, whispered in every culture throughout history, has now been formalized into a rigorous scientific discipline. We have moved from mythology to methodology, from staring at the constellations to analyzing the spectral absorption lines of distant planetary atmospheres. The primary tool in this grand endeavor is the concept of the circumstellar habitable zone, or what is more poetically known as the Goldilocks Zone. It is a deceptively simple idea that governs the most profound possibilities of the cosmos. Imagine every star, from the most brilliant blue giant to the dimmest red dwarf, radiating a sphere of energy. Within this sphere, there is a very specific, narrow orbital band where the stellar radiation is just right, not so intense that it boils away all water into space, and not so weak that water remains forever locked as ice. It is in this temperate cosmic shoreline that a rocky planet of sufficient mass could theoretically support liquid water on its surface, the one non-negotiable ingredient for life as we understand and conceive of it. This zone is the first filter we apply to the universe, a way of sifting through the trillions of stars to find the precious few that might harbor worlds like our own. Our target, the planet that so captivates our imagination, resides perfectly within this Goldilocks zone. But its star is not like our sun. It is a red dwarf, the most common type of star in the Milky Way galaxy. These stars are small, cool, and incredibly long-lived, potentially shining for trillions of years, far longer than the 10 billion-year lifespan of our own G-type main sequence star. This longevity is a profound advantage for the potential development of life, offering a stable environment for geological and biological timescales that dwarf our own. However, this proximity to a dim star comes with a significant and fascinating trade-off: tidal locking. Just as our moon always shows the same face to Earth, a planet orbiting this close to its parent star would have its rotation locked. This creates a world of stark contrasts: a substellar point on one side where the red sun hangs motionless in the sky, creating a permanent scorching desert, and a dark side on the other, a hemisphere of unending night and frozen nitrogen. The promise of habitability, therefore, is not a global phenomenon, but is likely confined to a specific region, the terminator line, a twilight ring of perpetual dawn or dusk separating the two extreme hemispheres, where the temperature gradients could allow for liquid water to exist in vast, flowing rivers, or perhaps even a circumglobal ocean. Detecting such a world required a leap in observational technology, a technique both elegant and stunningly simple in its conception: the transit method. Our space-based telescopes, like the Kepler and TESS missions, are essentially stellar photometers of unimaginable precision. They stare unflinchingly at a patch of the sky, sometimes for years, monitoring the brightness of hundreds of thousands of stars simultaneously. They are not looking for the planet itself, but for its shadow. When an orbiting planet passes directly between its star and our telescope, it blocks a minuscule fraction of the starlight, causing a slight, periodic dip in the star's brightness. This event, known as a transit, is our first clue. By measuring the depth of this dip, we can determine the planet's radius. By measuring the time between consecutive transits, we can calculate its orbital period, and thus its distance from the star. For our candidate planet, The data revealed a world approximately 1.1 times the radius of Earth, orbiting its red dwarf star every 37 days. This combination of size and orbital distance was the electrifying signal that placed it squarely in the habitable zone and marked it as a terrestrial or rocky world, rather than a gas giant, beginning its journey from a mere data point to a potential cradle of life. With the planet's size and orbit confirmed, the next great question is its mass, and from that, its density. This is where a second observational technique, the radial velocity method, becomes critical. As a planet orbits its star, its gravitational pull causes the star to wobble in its own tiny orbit. We can detect this stellar wobble by observing the star's light. As the star moves towards us in its wobble, its light is compressed, shifting towards the blue end of the spectrum. As it moves away, its light is stretched, shifting towards the red. This is the Doppler effect, the same phenomenon that changes the pitch of a passing siren. The magnitude of this wobble allows us to calculate the planet's mass. When this method was applied to our candidate system, the results were astounding. The calculated mass, combined with its known radius, suggested a density consistent with a composition of rock and iron, much like Earth, Venus, or Mars. This was a crucial piece of the puzzle. It ruled out the possibility that it was a mini Neptune, a small planet with a thick, crushing hydrogen-helium atmosphere. Instead, the data painted a picture of a solid world, a terrestrial sphere with a gravitational pull strong enough to hold onto a potential atmosphere and, just maybe, surface water. The presence of an atmosphere is the next critical factor for habitability, and perhaps the most complex to ascertain from light years away. An atmosphere acts as a planetary blanket, trapping heat and distributing it across the surface, which would be especially vital on a tidally locked world. It could transport warmth from the permanent day side to the twilight zone and the frigid night side, potentially widening the habitable band and creating more stable climates. Furthermore, a substantial atmosphere, like our own, would provide a crucial shield against harmful radiation. Red dwarf stars are known for their violent stellar flares, especially in their youth. These flares can blast their nearby planets with high-energy particles and X-rays, capable of stripping away an atmosphere and sterilizing a planet's surface. A world with a strong magnetic field, generated by a molten, rotating core, could deflect this radiation, creating beautiful auroras in its upper atmosphere while protecting any nascent life below. The grand challenge for the next generation of observatories, particularly the James Webb Space Telescope, is to perform transmission spectroscopy, analyzing the starlight that passes through the planet's atmosphere during a transit to search for the chemical fingerprints of gases like water vapor, carbon dioxide, methane, and oxygen, the building blocks and byproducts of a living world. Let us now descend, in our mind's eye, onto the surface of this potential second Earth. Standing in the twilight zone, the Terminator, we would be in a landscape of perpetual, sublime sunset. The star, a vast, dim crimson orb, would hang motionless at the horizon, never rising, never setting. It would cast long, stretched shadows that would remain fixed for millennia. The light would be muted, perhaps equivalent to the light on Earth an hour after sunset, but it would be constant. The sky above would likely not be blue. A planet orbiting a red dwarf would have an atmosphere that scatters red light less effectively than our own scatters blue light. Depending on its composition, the sky could be a pale yellow, a soft orange, or even a deep, brooding crimson. Overhead, the stars would be visible even during this day, a breathtaking canopy of unfamiliar constellations against a backdrop of the Milky Way's magnificent glowing band, far brighter and more detailed than we can see from Earth. Due to the lack of a bright, daylit sky, the air itself might feel different, perhaps denser if the atmospheric pressure is higher, and the constant winds flowing from the hot hemisphere to the cold would be a defining feature of the environment. A persistent, directional breeze carrying the scent of alien rain or dust. The botany of a red dwarf world would be a masterclass in evolutionary adaptation. On Earth, plants evolved to absorb the peak energy output of our yellow-white sun, which is in the blue and red parts of the spectrum, while reflecting green light, which is why our world is so verdant. On a planet around a red dwarf, the vast majority of light energy is in the far red and infrared part of the spectrum. To thrive, photosynthetic life would need to evolve pigments capable of capturing these lower energy photons. This would likely mean that plants would be very dark, perhaps appearing deep purple, crimson, or even black to our eyes, in order to absorb as much of the available light as possible. Imagine forests of towering, black, feathery flora, their leaves designed for maximum surface area to catch the faint, perpetual twilight. The evolutionary pressure for light would be immense. Perhaps some plants would be bioluminescent, creating their own light from metabolic processes, or developing symbiotic relationships with fungi that could process geothermal energy from the planet's interior. The entire food web would be built upon this foundation of dark, efficient photosynthesis, creating a world that is at once both alien and deeply, logically familiar in its adherence to the universal principles of evolution. The question of water on this world is paramount. The confirmation of its terrestrial nature and its position in the habitable zone strongly implies that water could exist. But in what form? On the scorching day side, any water would be baked away into vapor, creating a thick, humid greenhouse atmosphere. On the frigid night side, it would be locked into vast glaciers of ice, perhaps miles thick, a continent of permanent winter. The magic would happen in the Terminator Zone. Here, meltwater from the edge of the dayside inferno could form rivers that flow towards the cold, carving canyons and valleys. These rivers might pool into vast lakes, or even a planet-encircling ocean that is in a constant state of partial freezing on one side and evaporation on the other. This eyeball planet configuration, with a liquid water ring or ocean, is a leading model for tidally locked habitable worlds. The weather would be dominated by this hydrological cycle. Massive storm systems, driven by the extreme temperature differential, would perpetually form over the dayside ocean, carrying enormous amounts of water vapor across the Terminator to fall as torrential rain or snow, creating a dynamic, wet, and potentially life-bearing environment in that narrow, temperate band of twilight. Even with all these promising conditions, the challenges to life, and especially to human colonization, are formidable. The intense radiation from stellar flares remains a primary concern. While a strong magnetosphere and a thick atmosphere would offer protection, the frequency and intensity of these events could create a hazardous radiation environment on the surface. Any human habitat would likely need to be shielded, perhaps built underground or within deep canyons, to provide adequate protection. The tidal locking itself presents another challenge. The lack of a day-night cycle could have profound and unknown psychological and biological effects on human beings who have evolved over millions of years to a 24-hour circadian rhythm. Furthermore, the gravity might be slightly different. A planet 1.1 times Earth's radius but with a similar density would have a slightly higher surface gravity, perhaps 10 to 20% stronger. While not insurmountable, this would mean everything feels heavier, and it would place a constant, additional strain on our bodies. These are not reasons for despair, but are critical engineering and biological problems that would need to be solved, puzzles presented by the universe that our ingenuity would be called upon to answer before we could truly call this new world a home. The journey itself represents the greatest hurdle of all. This promising world, while close in cosmic terms, is likely dozens of light years away. With our current propulsion technology, a voyage would take tens of thousands of years, an impossible timescale for a human crew. The dream of reaching this second Earth is therefore inextricably linked to the dream of developing new physics, propulsion systems that could approach the speed of light, whether through matter-antimatter annihilation, fusion rockets, or even more exotic concepts like warp drives that bend the fabric of space-time itself. Alternatively, it would require the construction of world ships, vast, self-sustaining multi-generational vessels that would carry a fragment of Earth's biosphere and human civilization across the interstellar void. The inhabitants of such a ship would live and die on the journey, their distant descendants being the ones to finally gaze upon the crimson sun and alien landscapes of their destination. The discovery of this planet is therefore not just a discovery, it is a catalyst, a tangible goal that could drive scientific and technological progress for centuries, a unifying purpose for a species that has always found its greatest strength in reaching for the impossible. Let's delve deeper into the nature of the parent star, this M-class red dwarf that serves as the anchor for our potential new home. Unlike our sun, which is in the vibrant middle age of its life, red dwarfs are the ancient Methuselahs of the cosmos. Because they burn their hydrogen fuel so slowly and efficiently through convection, their lifespans can extend into the trillions of years, a time so vast that the current age of the universe is but a brief prelude. This provides an almost unimaginably long period of stability for life to arise and evolve. While our sun will eventually swell into a red giant and consume the Earth in about 5 billion years, this red dwarf will still be serenely shining, barely changed, when the universe is hundreds of times older than it is today. This extended timeline allows for evolutionary pathways that are impossible to conceive of in our own solar system. Complex ecosystems could have had time to develop extraordinary resilience, and intelligence, if it arose, could be ancient beyond our comprehension. This temporal gift, however, comes with the aforementioned caveat of a turbulent youth. For its first billion years, a red dwarf is highly active, lashing its inner planets with powerful flares that could erode atmospheres and make the surface inhospitable, a cosmic trial by fire that any world must survive to reach the long, peaceful main sequence of its star's life. The very chemistry of the starlight would shape this world in fundamental ways. Our sun's spectrum is rich in blue and ultraviolet light, which drives certain chemical reactions in our atmosphere, such as the formation of the ozone layer that protects us. A red dwarf's light is heavily skewed towards the red and infrared. This lack of high-energy photons would mean an oxygen-rich atmosphere on such a world would likely be devoid of a significant ozone shield. Protection from ultraviolet radiation from flares would have to come from other sources, perhaps a thicker atmospheric column or biological adaptations such as organisms that live underground or underwater, or which have evolved their own biochemical sunscreens. This different light spectrum also impacts the very process of vision. Life evolving on such a world might have eyes that are sensitive to the near-infrared, allowing them to perceive a world of thermal gradients and subtle light that would be completely invisible to us. What we would perceive as a dim twilight landscape could, to a native creature, be a vibrant and richly detailed environment. Our understanding of light and vision is deeply biased by our own star, and this new world forces us to imagine a completely different sensory reality, built upon a different slice of the electromagnetic spectrum. The geology of a tidally locked super-Earth candidate would be unlike anything in our solar system. The constant gravitational pull from one direction, combined with the extreme temperature differential between the day and night sides, would create immense geological stress. This could lead to unique tectonic activity, not of drifting continents like on Earth, but perhaps of a single, cracked supercontinent on the day side, with massive fault lines radiating from the substellar point. Volcanoes might be more prevalent along the Terminator line, where the thermal stress is greatest, providing a constant source of geothermal energy and releasing essential gases and minerals into the atmosphere and oceans. This volcanism could be a key driver of long-term climate stability, replenishing carbon dioxide to maintain a greenhouse effect that prevents the planet from freezing over completely. These hotspots along the twilight ring could become cradles for chemosynthetic life, organisms that derive their energy not from sunlight, but from the chemical reactions of volcanic vents on the deep ocean floor, entirely independent of the red dwarf sun hanging at the horizon. This suggests the possibility of two separate biospheres, one photosynthetic, one chemosynthetic, coexisting on the same world. The potential for a global ocean, girdling the planet in the Terminator Zone, presents a fascinating scenario for the distribution of life and heat. This ring ocean would be subject to powerful planet-spanning currents. Warm water from the edge of the dayside would constantly flow towards the colder, nightside boundary, creating a massive thermal conveyor belt. This process would be far more efficient at distributing heat than wind alone, potentially widening the band of habitability significantly. It could mean that even a few degrees into the permanent night or day hemispheres, the climate could remain temperate due to the ocean's moderating influence. Such an ocean could be teeming with life, which would migrate with the currents. Imagine vast, floating forests of the dark, alien seaweed, or great shoals of bioluminescent creatures moving through the perpetual twilight. For human explorers, this ocean would be a primary target for investigation. It would be a repository of the planet's history, its sediments holding a fossil record of how life adapted to this unique environment. Probes descending into its dark alien depths would be searching for the very origins of life on this world, looking for the common chemical pathways that might unite all life across the galaxy. Let us reconsider the sky. The lack of a bright, sun-drenched sky means that the cosmos would be an ever-present reality for any inhabitant of this world. Astronomy would not be a niche science. It would be the unavoidable backdrop of existence. The view would be spectacular. With the parent star fixed at the horizon, the rest of the celestial sphere would appear to rotate around a point directly overhead. Stars would not rise and set, but would trace perfect circles in the sky over the course of the planet's day, which is equal to its year. This would give any observer a profound, intuitive understanding of celestial mechanics. The Milky Way would be a permanent, blazing river of light. Other galaxies, like Andromeda, would be visible to the naked eye as distinct, hazy patches. This constant, unobscured view of the universe could shape the philosophy, religion, and science of any intelligent species that evolved there. They might never develop the geocentric view that dominated early human thought, as their relationship with the cosmos would be far more direct and obvious. They would be born with the knowledge that their world is just one of many, drifting in an infinite star-dusted sea. The soundscape of this world would be equally alien. On Earth, much of our ambient sound is generated by life and by weather patterns driven by planetary rotation. On a tidally locked world, the dominant sound would likely be the wind. Not a chaotic, gusting wind, but a persistent, directional moan as the atmosphere endlessly circulates from the hot side to the cold. In the Terminator Zone, this would be a constant presence, a low-frequency hum that would be the baseline of all auditory experience. Near the oceans, this would be joined by the sound of alien waves crashing on a shore, their rhythm dictated by the planet's unique gravity and atmospheric pressure. Volcanic rumbles might echo from the geothermal hotspots. And what of life? Would the black forests be silent, or would they be filled with the percussive clicks and strange calls of creatures adapted to a world without a bright morning chorus? The absence of a day-night cycle would mean that the rhythms of life would be tied to other cues, perhaps the subtle shifts in the wind, or the tidal pulls of other moons in the system, creating a symphony of sounds completely foreign to human ears. The James Webb Space Telescope represents our first real opportunity to move from speculation to observation regarding this planet's atmosphere. Its primary method, transmission spectroscopy, is an act of cosmic artistry. As the planet transits its star, a tiny fraction of the starlight filters through the very top layers of its atmosphere. Molecules within that atmosphere absorb specific wavelengths of light, leaving tiny dark lines, an absorption spectrum imprinted on the starlight that reaches us. JWST is so sensitive that it can detect these minuscule spectral fingerprints from light years away. It will be looking for the unmistakable signatures of water vapor, H2O, a key indicator of a hydrological cycle. It will search for carbon dioxide, CO2, a greenhouse gas essential for maintaining temperature. And it will hunt for methane, CH4, and oxygen, O2, a combination of gases that, on Earth, is almost exclusively produced by biological activity. Finding both methane and oxygen in the same atmosphere would be a monumental discovery, a so-called biosignature, as these two gases normally destroy each other and their coexistence strongly implies a constant, massive source replenishing them like a global biosphere. This would be the closest we could get to confirming life without actually going there. The discovery of such a world forces a profound re-evaluation of the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for it. Perhaps the answer is not that life is rare, but that the dominant form of life-hosting star system is fundamentally different from our own. Red dwarf systems are far more common and far longer lived. It's plausible that most life in the galaxy has arisen on tidally locked planets orbiting these dim red suns. Such civilizations, if they exist, might be ancient and technologically advanced, but they might have no incentive to broadcast their existence with powerful radio signals. Living under the constant threat of stellar flares, they might have developed a culture of caution, a silent forest philosophy of not drawing attention to themselves. Their technology might be focused on sustainability and planetary defense rather than interstellar expansion. The discovery of this second Earth candidate doesn't just give us a place to look for life. It provides a new framework for how to look, suggesting we should be searching for the subtle atmospheric byproducts of biology rather than waiting for an explicit hello from the stars. If we were to one day establish a human presence on this world, the very concept of time would need to be reinvented. Our entire system of seconds, minutes, hours, and days is based on the rotation of the Earth. On a tidally locked planet, a day is the same length as a year, the time it takes to orbit the star. For our candidate, this might be 37 Earth days. There would be no sunrises or sunsets to mark the passage of time. Clocks would become purely abstract, untethered from the natural cycles that have governed life for billions of years on Earth. Perhaps human colonists would maintain an artificial 24-hour cycle with simulated lighting inside their habitats to regulate their circadian rhythms. Or perhaps over generations, they would adapt to a new sense of time, their culture and language evolving to reflect a state of perpetual twilight. The idea of a workday or night would become meaningless. Instead, life might be structured around other, more subtle cycles, such as the slow wobble of the planet's axis or the periodic alignments of its sibling planets in the sky. It would be a fundamental reshaping of the human experience of reality. Let's consider the sibling planets that might share this solar system. It's rare for a star to form just one planet. Our candidate is likely part of a larger family of worlds, each shaped by its distance from the red dwarf. There might be an inner, scorched world, a Mercury analog with a molten surface. There could be outer, frozen gas giants or ice worlds, their surfaces decorated with cryovolcanoes erupting plumes of water, ice, and ammonia. These other planets would be a constant feature in the sky of our second Earth. They would appear as brilliant, star-like points or even small resolvable disks, tracing their own circular paths through the darkness. Their gravitational influence would be felt, creating subtle tides in the oceans and atmosphere of our habitable world. For future colonists, these neighbor worlds would be irresistible targets for exploration, resource extraction, and scientific study. This single habitable planet would not be an isolated outpost, but a foothold in a completely new and unexplored solar system, a base camp for the human exploration of an entirely new cosmic neighborhood, rich with its own wonders and its own secrets waiting to be uncovered. The atmospheric pressure on a super-Earth, like our candidate, is a critical variable for habitability. Being slightly larger and more massive than Earth, its gravity would be more effective at holding onto its atmosphere over geological time. This could mean the air is significantly thicker, with a surface pressure 1.5 to 2 times that of Earth. While a human could breathe a properly constituted air mixture at this pressure, the environment would feel different. Sound would travel more effectively, making distant noises clearer. The effort of moving, of breathing, would be subtly increased. Aerodynamic flight would be easier, perhaps allowing for flying creatures of a larger size than on Earth, or for more efficient human aircraft. A thicker atmosphere would also be a more effective shield against cosmic rays and micrometeoroids, making the surface a safer place. It would produce more dramatic weather phenomena, more powerful winds, denser clouds, and perhaps rainbows and halos of a completely different character, formed by light from the red star refracting through alien ice crystals or raindrops in the thick, soupy air. This dense atmospheric blanket is a key part of what could make this world a stable, protected cradle for life. The magnetic field of this planet would be its invisible night, its primary defense against the fury of its own sun. Generated by the churning of a liquid iron core, the magnetosphere would extend far out into space, deflecting the charged particles of the stellar wind and the far more energetic particles from coronal mass ejections. On a tidally locked planet, the nature of this core dynamo is a subject of intense scientific debate. Without rapid rotation, would a planet still generate a strong, stable magnetic field? Some models suggest that even slow rotation, combined with strong convection in the mantle, driven by the intense day-side heating, could be sufficient to power a protective magnetic shield. The visual manifestation of this shield would be aurorae. But unlike on Earth, where they are largely confined to the polar regions, on a tidally locked world, the aurorae might form 2 vast, shimmering rings around the magnetic poles, or perhaps a single immense auroral crown above the dark side of the planet, where the stellar wind particles are funneled in. It would be a permanent, silent, and breathtakingly beautiful light show, a cosmic reminder of the invisible forces that make life possible. We must also consider the possibility that we are not the first. Given the immense age of the red dwarf star, If life arose on this planet, it has had billions of years more to evolve than life on Earth. That is more than enough time for intelligence to emerge, develop technology, and perhaps even transcend it. When our probes finally arrive, we may not find a pristine wilderness, but a world bearing the unmistakable signs of a technological civilization, either past or present. Perhaps we will find the ruins of ancient cities, half buried in the dust of the Terminator Zone. Perhaps we will detect the faint residual heat of vast industrial processes, or the unnatural geometric shapes of orbital structures. Or perhaps the civilization is still there, but has evolved in ways we cannot comprehend. They may exist in a non-physical form, as pure information in a planetary computer, or have integrated themselves so perfectly with their planet's biosphere that their technology is indistinguishable from nature. The search for a second Earth is therefore also implicitly a search for our cosmic neighbors, and we must be prepared for the possibility that the house we are looking at is already occupied. The journey to this world would redefine the human spirit. A multi-generational starship, a self-contained world in miniature, would be one of the most complex and ambitious engineering projects ever undertaken. It would need a perfectly closed-loop life support system, recycling every molecule of air, water, and waste. It would need a robust social and political structure to maintain stability over centuries. The psychological toll on its inhabitants, born in deep space, destined for a world they will never see but which their descendants will inherit, is immense. They would be a new branch of humanity, starfolk. Their culture shaped by the silence of the void and the distant, unwavering light of their destination star. Their art, their music, their philosophy would all be centered around the promise, the destination world. The logs and records they keep during their centuries-long voyage would become a new kind of sacred text, the founding epic of a new civilization. The starship itself would be a testament to the power of a unified human vision, a message in a bottle sent across the cosmic ocean, carrying the seed of consciousness to a new shore. Upon arrival, the first priority for human explorers would be a process known as in situ resource utilization. Living on another world is not feasible if you have to ship everything from Earth. The planet itself must provide the raw materials for survival and expansion. The atmosphere, if it contains carbon dioxide and nitrogen, could be processed to produce breathable air and fertilizer for growing food. Water ice, likely abundant on the night side, could be mined and melted to provide water for drinking, agriculture, and to be split into hydrogen and oxygen for rocket fuel. The regolith, the planet's soil and rock, would be analyzed for essential metals and minerals to be used in 3D printing and manufacturing, allowing the colonists to build habitats, tools, and vehicles on-site. The goal would be to create a self-sustaining outpost, a settlement that can grow and thrive independently of Earth. This bootstrapping process, turning alien rock and air into a viable human colony, would be a monumental challenge. But it is the only way that a true, permanent second home for humanity can be established among the stars. The color of the water in the oceans of this second Earth would be a fascinating consequence of the local star and atmosphere. On our Earth, the ocean appears blue because water absorbs longer, redder wavelengths of light more strongly, and what is left to be scattered back to our eyes is the blue light. Under a dim red sun, there is very little blue light to begin with. The light penetrating the water would be predominantly red and infrared. If the water is very pure, it might appear strikingly black, absorbing all the faint light that reaches it. However, if the water is filled with microscopic life, as our oceans are, the color could be completely different. Alien phytoplankton, evolved to photosynthesize red light, might contain pigments that make the water appear deep violet, or even a shimmering, oily green if they reflect a different part of the spectrum. The visual impact of standing on a shoreline and seeing a vast, dark purple ocean stretching to a horizon where a crimson sun hangs motionless would be an awe-inspiring and profoundly alien experience, a visual symphony composed in a different cosmic key. The legal and ethical framework for such a discovery would be a new frontier for humanity. Who owns this new world? Does it belong to the nation or private entity that discovers it? Or is it the common heritage of all humankind? The Outer Space Treaty of 1967 forbids nations from claiming sovereignty over celestial bodies. But it was written before the discovery of potentially habitable exoplanets was a reality. If the planet is found to harbor its own life, even if it's only microbial, our moral obligations become immensely more complex. Do we have the right to introduce Earth life, potentially causing an extinction event for the native biosphere? This is the principle of planetary protection. Taken to its ultimate conclusion, the discovery of a second Earth would necessitate the creation of a new body of interstellar law, a framework to ensure that our first steps into the galaxy are taken with wisdom, foresight, and a profound respect for the universe we are exploring, ensuring we don't repeat the mistakes of our own colonial past on a cosmic scale. The impact on human culture, philosophy, and religion would be revolutionary. For millennia, our stories and beliefs have been Earth-centric, predicated on the idea that this world is the sole, unique stage for the human drama. The confirmation of a second, viable Earth would shatter that paradigm forever. It would provide tangible proof that the universe is not hostile or empty, but creative and fecund, capable of producing cradles for life in abundance. This could foster a new, cosmic humanism, a sense of shared identity not tied to a nation or a continent, but to our status as Earthlings poised to become Galaxians. It might inspire a renaissance in art and music, as we try to capture the wonder of alien landscapes and crimson suns. For some, it would be seen as the fulfillment of a divine plan. For others, a magnificent testament to the unguided power of natural laws. But for everyone, it would permanently expand our sense of the possible, and in doing so, it would change what it means to be human. Let's imagine the very first probe to enter orbit around this world. After a journey of decades, it would awaken and begin its survey. The initial images sent back across the light years would be the most anticipated data in human history. We would see, for the first time, not a CGI reconstruction, but the reality. Are there continents and oceans? What color is the sky? Are the clouds white or are they tinged with alien chemicals? The probe's sensors would build a global map, charting temperatures, topography, and gravity. Its spectrometers would perform a detailed chemical analysis of the atmosphere, confirming the presence of water, and searching for those telltale biosignatures of oxygen and methane. Every new piece of data would fill in another brushstroke on the portrait of this new world. For the scientists and for the public watching back on Earth, it would be a moment of supreme revelation, the culmination of centuries of looking up at the night sky and wondering. The data stream from that single lonely probe would be a message from the future of humanity to its present. The existence of a strong magnetic field, while crucial for protecting against stellar radiation, would also have implications for navigation and technology. Compasses would work, but they wouldn't point to a geographic North Pole aligned with the axis of rotation. Instead, they would point to the planet's magnetic poles, which could be located anywhere. On a tidally locked world, this could mean a compass might point straight up, or towards the horizon, depending on your location. This would create a unique navigational challenge. Furthermore, a powerful magnetosphere could interact with technology in unexpected ways. Radio communication might be subject to different kinds of interference. The intense auroral displays could induce electrical currents in long conductors on the surface, a hazard that would need to be engineered around. Understanding the planet's magnetic environment would be just as critical as understanding its geology or atmosphere. It's another layer of the complex, interconnected system that makes up a world, a reminder that every aspect of a planet's physics, from its core to the edge of its atmosphere, plays a role in its potential to harbor life and host a human civilization. If this world has moons, they would add another layer of complexity and beauty. A large moon like our own could provide tidal forces that, even on a tidally locked planet, might help circulate ocean water and prevent the atmosphere from freezing out on the dark side. It could also stabilize the planet's axial tilt, leading to more regular and predictable climate zones. From the surface, a moon would trace its own path across the star-dusted sky, going through phases just as our moon does. Imagine standing in the perpetual twilight and watching a massive, cratered moon rise, its face illuminated by the faint crimson light of the local sun. If the system has multiple moons, the sky would be a constant, slow-motion celestial dance of orbiting bodies, a cosmic clockwork that would be the basis for calendars and mythology. These moons would also be prime targets for early exploration and resource acquisition, perhaps serving as staging posts or communication relays for a budding interplanetary civilization. They are not just scenic additions, they are active participants in the planet's environmental system. The potential for life in the subsurface of the planet cannot be overlooked. Even if the surface is hostile due to radiation or extreme temperatures, the conditions a few meters or kilometers underground could be far more stable. On the frigid night side, geothermal heat from the planet's core could warm deep rock, creating vast liquid water aquifers, completely shielded from the dangers of space. Life in these subterranean oceans would be chemosynthetic, drawing energy from chemical gradients in the water and rock, entirely independent of the star. It would be a shadow biosphere, a hidden world of life that could be far more extensive than any life on the surface. We are discovering on Earth that microbial life can exist deep within the planet's crust, and the same could be true, or even more true, on this alien world. Exploring this realm would require drilling through miles of ice and rock, a technological challenge of immense proportions. But the reward would be access to an ecosystem that has been evolving in isolation for billions of years. A treasure trove of alien biology that could hold the key to understanding the full range of life's adaptability. The psychological adaptation of colonists would be a critical field of study. Humans are profoundly influenced by their environment, by the colors, sounds, and rhythms of the natural world. How would the human mind react to a permanent red twilight? To a sky that is always dark? To a wind that always blows from the same direction? It's possible that new psychological conditions could emerge, unique to the planetary environment. The lack of a blue sky, which has been shown to have a calming effect, might need to be compensated for with specific lighting within habitats. The sense of isolation, being on a tiny outpost of life separated from Earth by an uncrossable gulf of space, would be immense. The colonists would need to develop extraordinary psychological resilience and a deep, shared culture rooted in their unique situation. They would be the first true exoplanetarians, their minds and identities forged by the light of a different star. Their art, their stories, and their mental frameworks would be a fascinating new chapter in the story of human consciousness. The speed of information exchange with this world would shape its relationship with Earth. Even at the speed of light, a message sent from the colony to Earth and a reply sent back could take decades. There would be no real-time conversation, no instant news updates. The colony would develop in relative isolation, its culture evolving on its own trajectory. News from Earth would be historical by the time it arrived. Major events, scientific breakthroughs, and cultural shifts on Earth would be received by the colonists as chapters from a history book. Likewise, reports from the colony would give Earth a delayed, episodic glimpse into the progress of its first interstellar child. This latency would foster independence and self-reliance. The colony would have to solve its own problems, make its own decisions, and forge its own destiny, knowing that help or guidance from home is years, if not a lifetime, away. This communication lag is a fundamental condition of interstellar civilization, enforcing a separation that is not just spatial, but temporal as well. The first generation of children born on this new world would represent a pivotal moment in human history. They would be native to a planet other than Earth. Their bodies would develop under a different gravity, their eyes would know only a crimson sun, and their lungs would breathe an atmosphere manufactured and maintained by technology. Earth would be a place of legend to them, a beautiful blue and white marble in their history lessons, a place they could never visit due to the biological challenges of returning to a higher gravity, different environment. They would be the first of a new, distinct branch of the human species, Homo interstellaris. Their perspective would be unique. They would have no innate, evolutionary memory of Earth's savannas or forests. Their sense of home would be a world of twilight, dark flora, and a constant view of the galactic core. Their emergence would be the ultimate fulfillment of the quest for a second Earth. Not just a place for humans to live, but a place for humanity to be reborn, to continue its long story under a new star. Let us contemplate the immense silence of the journey. The starship, a tiny arc of metal and life, would traverse a void of almost perfect emptiness. For centuries, the view from the cockpit would be nearly unchanging. A tapestry of stars, frozen in their positions, with the destination star growing imperceptibly brighter with each passing decade. The crew would live in a world of humming machinery, recycled air, and artificial light. The concept of outside would be a lethal vacuum. This profound isolation could foster a deep sense of introspection and community. The shared purpose of the voyage would be the unifying principle of their society. They would become masters of sustainability, of psychology, of living in a closed system, because failure in any of these areas would mean the end of the mission. The lessons learned by the society aboard this starship could be as valuable to humanity as the discovery of the planet itself, providing a blueprint for how to live sustainably and cooperatively, whether it's on a vessel crossing the stars or on our own precious, finite world. The mineralogy of this planet could be significantly different from Earth's. The chemical composition of the protoplanetary disk from which it formed would determine the abundance of various elements. Perhaps this world is unusually rich in certain rare earth metals, or deficient in others we consider common. This would have a huge impact on the development of both life and technology. A lack of accessible iron could make the development of an industrial civilization difficult, while an abundance of elements like lithium or titanium could fast-track certain technological paths. The very color of the rocks and soil would be determined by this unique elemental cocktail. We might not find continents of familiar brown and gray granite, but landscapes of blue-tinged rock or soil that shines with metallic flecks. The first geological surveys would be a treasure hunt, not just for resources, but for a fundamental understanding of how this world was built, atom by atom, from the dust of a stellar nursery billions of years ago. This alien geology is the very foundation upon which all other possibilities of life, of colonization, are built. The very definition of life might need to be expanded. While we search for life as we know it based on carbon and water, the universe might be more creative. Could there be life forms that use a different solvent, like liquid methane or ammonia on colder worlds? Could silicon, an element with similar bonding properties to carbon, form the basis for life in a different temperature range? Our candidate planet seems ideal for water-based life, but the discovery of any life, no matter how simple, would force us to confront these deeper questions. If we find microbes on this second Earth that share a common DNA-based biochemistry with us, it might suggest that life originated elsewhere and was spread between star systems, a theory known as panspermia. If we find life that is biochemically completely different, it would suggest that life arises independently wherever the conditions are right, and that the universe is teeming with a diversity of biological systems that we have only just begun to imagine. The discovery is not just about finding life, but about understanding the fundamental principles of biology on a cosmic scale. The climate modeling for a tidally locked planet is a complex and fascinating field. Supercomputers are used to simulate how an atmosphere would behave under such extreme conditions. The most robust models suggest that a thick enough atmosphere would prevent the night side from becoming so cold that the atmosphere itself freezes and collapses onto the surface, a process called atmospheric collapse. Instead, powerful, planet-girdling winds would create a single, massive Hadley cell, with warm air rising at the substellar point, traveling at high altitude to the night side, cooling and sinking, and then returning to the day side as a surface-level wind. This global circulation is the engine that makes the Terminator Zone habitable. It's a stable, predictable weather system, but one prone to immense storms where the hot and cold air masses meet. Understanding and predicting this alien weather would be day-one priority for any colonists, essential for agriculture, transportation, and the safety of any structures built on the surface. The long-term evolutionary trajectory of humanity on this new world would be a grand, uncontrolled experiment. Over thousands of years living under lower or higher gravity, exposed to a different spectrum of light, and adapting to a new environment, the human form itself might begin to change. Natural selection would favor traits suited to the new home. Perhaps colonists would evolve to be taller and more slender in lower gravity, or more robust and stocky in higher gravity. Their skin pigmentation might adapt to the unique radiation environment. Their eyes might even develop a greater sensitivity to red light. Given enough time and enough isolation from Earth, a new, distinct species of human could arise. This is the ultimate implication of becoming a multiplanetary species. Not just the expansion of our civilization, but the diversification of our very biology. We would be seeding the galaxy, not just with our culture and technology, but but with our potential for future evolution, allowing humanity to explore different paths of existence on different worlds. The concept of agriculture would be completely reimagined. Earthly plants are optimized for a 24-hour light cycle, and the spectrum of a yellow sun, they would likely not survive on the surface of our candidate world. Instead, colonists would have two choices. The first is to grow genetically modified earth crops inside vast, artificially lit biodomes, recreating a piece of home in the alien landscape. The second, more ambitious path is to engage in xenofarming. If the planet has its own native flora, scientists could study its biochemistry and domesticate it, learning to cultivate the black, leafy plants of the Terminator Zone. This would involve creating a whole new science of alien agriculture, understanding a new ecosystem from the ground up. The food that would be produced would be utterly foreign, with different textures, colors, and nutritional properties. The success of a long-term colony would depend on its ability to wean itself off imported Earth-based food and learn to live off the land of its new home, a process of integration with the alien biosphere that would be the ultimate sign of a successful colonization. The planetary system's age offers a sobering perspective on cosmic timescales. If this system is, for example, 8 billion years old, it is almost twice the age of our own solar system. This means that when the first microbial life was emerging on Earth, this world had already existed for longer than Earth has existed today. It has had billions of years of quiet, stable conditions for complex processes to unfold. This temporal gulf is difficult for the human mind to grasp. It raises the profound possibility of sequential life. A civilization could have risen on this world, flourished for millions of years, and then gone extinct, all before the dinosaurs even appeared on Earth. We might arrive to find not a living civilization, but its technological fossils. Satellites in decaying orbits, the faint spectral signatures of industrial pollutants trapped in ancient ice layers, or the eroded foundations of structures built by beings who have been gone for a geologic age. The planet could be a ghost world, a cosmic archaeological site that holds the story of another's rise and fall, a cautionary tale written across an entire world. A tidally locked world might possess a unique form of hydrological cycle. The constant evaporation on the day side and deposition of ice on the night side would, without a return mechanism, eventually trap all the planet's surface water in a massive glacier on the dark hemisphere. For the Terminator Zone to remain wet, there must be a way for this water to return. One possibility is through glacial flow. The immense weight of the nightside glacier could cause it to slowly flow, like glaciers on Earth, back towards the warmer Terminator, where it would melt, replenishing the rivers and oceans. Another possibility is a subsurface aquifer system. Meltwater on the dayside fringe could seep underground, flowing through a warm, geothermally heated crust beneath the ice cap and re-emerge from springs on the other side. This planet-spanning plumbing system would be the lifeblood of the world, a slow, steady, and hidden circulation that maintains the delicate equilibrium of the habitable zone, ensuring that the cradle of life does not run dry over the eons. The discovery of this world is a powerful antidote to existential despair. In an age where humanity faces global challenges and a sense of uncertainty about the long-term future, the knowledge that there is another potential home, a backup for humanity and Earth's biosphere, provides a profound sense of hope. It doesn't solve our immediate problems, but it reframes them against a much larger canvas. It gives our species a long-term unifying project that transcends national politics and short-term economic cycles. The effort to reach and understand this world could spur the very technologies in energy, life support, and sustainability that we need to better manage our own planet. It is a dual journey. As we reach for the stars, we may find the solutions we need back at home. The quest for a second Earth is, in many ways, a quest to ensure the survival and flourishing of the first, a testament to our instinct not just to survive, but to explore, to grow, and to carry the light of consciousness forward into the cosmos. Let us imagine the first human footstep on this new world. After the long voyage, after the careful robotic surveys, a small crew would make the final descent in a lander. They would touch down in the strange, crimson twilight of the Terminator Zone. The astronaut, encased in a protective suit, would descend the ladder and place a boot onto the alien soil. In that single moment, humanity would become a multi-planetary species. It would be a moment of quiet, profound significance, broadcast back to a waiting Earth. There would be no cheering crowds on this new world, only the sound of the wind and the astronauts' own breathing. It would be a moment of arrival, but also a beginning, the start of the monumental task of building a new branch of civilization. That single footstep would represent the hopes and dreams of every human who has ever looked at the stars and wondered. A promise made by our ancestors finally fulfilled on a shore of unimaginable distance. It would be the dawn of a new age for life from Earth. The planetary rings, if this world has them, would be a spectacular feature. Unlike Saturn's bright, icy rings, rings around a planet in the habitable zone would likely be darker, composed of rock and dust captured from asteroids or a shattered moon. From the surface, this ring system would appear as a breathtaking, solid arch, stretching from horizon to horizon. In the perpetual twilight of the Terminator Zone, this arch would be permanently visible, a fixed feature of the celestial landscape. Its color would depend on its composition, perhaps a dark charcoal gray or a deep, dusty red. The side of the ring facing the star would be faintly illuminated, while the side facing away would be a band of pure black, obscuring the stars behind it. The ever-present sight of such a colossal structure in the sky would undoubtedly have a profound impact on art, mythology, and the psychological state of any inhabitants. A constant and beautiful reminder of the complex and dynamic cosmic neighborhood they now call home. The social structure of a founding colony would have to be meticulously planned. A small, isolated population is vulnerable to social friction and psychological stress. The first colonists would likely be selected not just for their technical skills, but for their psychological stability, cooperativeness, and problem-solving abilities. The initial form of governance would need to be robust, perhaps a hybrid of democratic principles and a clear command structure for emergency situations. Every colonist would have multiple roles and a deep sense of interdependence. The community's survival would depend on their ability to work together to overcome unforeseen challenges, from equipment malfunctions to medical emergencies. The founding charter of such a colony would become a document of immense historical importance, outlining the principles of a new society, a society born from science, reason, and the shared dream of planting human roots in the soil of another world. It would be a social experiment on the grandest possible scale. Let us contemplate the end of this journey, not the end of the story, but the end of the beginning. After the first landing, after the establishment of the first permanent habitat, the era of exploration would slowly transition into an era of settlement. The outpost would grow, powered by local resources, its population expanding with children born on the new world. The daily life of the colonists would become a routine of science, maintenance, and expansion. The profound alienness of their environment would become their new normal. The crimson sun, the dark plants, the constant wind, these would be the features of home. They would look up at the sky and see Earth as a bright, distant star, a symbol of their origin, but no longer their home. They would have successfully completed the most audacious migration in human history. They would be the custodians of a second Genesis, the keepers of a fragile flame of consciousness, ensuring that even if disaster were to befall Earth, the human story, the story of life and thought and wonder, would not come to an end. And so, this world remains for now a point of light, a whisper in the data, a destination in our collective imagination. It is a symbol of what we are capable of when we apply our curiosity and intellect to the grandest questions. The search for a second Earth is a mirror held up to ourselves. It reflects our own fragility, the preciousness of our own world, and our deepest, most noble aspirations. Whether we ever set foot on its soil or not, its very existence has already changed us. It has expanded the boundaries of our dreams and reminded us that we are part of a vast, creative, and still largely unexplored cosmos. The journey is far from over. In truth, it has just begun. And as we continue to gaze into the deep, we do so with a renewed sense of wonder and the quiet, persistent hope that somewhere, waiting for us across the sea of stars, is a world that we can one day call home. Even with all these promising conditions, the challenges to life, and especially to human colonization, are formidable. The intense radiation from stellar flares remains a primary concern. While a strong magnetosphere and a thick atmosphere would offer protection, The frequency and intensity of these events could create a hazardous radiation environment on the surface. Any human habitat would likely need to be shielded, perhaps built underground or within deep canyons, to provide adequate protection. The tidal locking itself presents another challenge. The lack of a day-night cycle could have profound and unknown psychological and biological effects on human beings, who have evolved over millions of years to a 24-hour circadian rhythm. Furthermore, the gravity might be slightly different. A planet 1.1 times Earth's radius, but with a similar density, would have a slightly higher surface gravity, perhaps 10 to 20% stronger. While not insurmountable, this would mean everything feels heavier, and it would place a constant, additional strain on our bodies. These are not just reasons for despair, but are critical engineering and biological problems that would need to be solved, puzzles presented by the universe that our ingenuity would be called upon to answer before we could truly call this new world a home. The search for biosignatures extends beyond atmospheric gases. Future telescopes might be able to detect the red edge of vegetation. On Earth, plant leaves absorb red light for photosynthesis but strongly reflect near-infrared light, causing a sharp, detectable spike in reflectivity at that wavelength. This is the vegetative red edge. Alien plants using different pigments to photosynthesize light from a red dwarf might have a similar feature, but shifted to a different, longer wavelength, a purple edge, for instance. Detecting such a spectral signature from the surface of our candidate planet would be incredibly strong evidence for a widespread photosynthetically active biosphere. It would be like seeing the green of Earth's forests from light years away. Another potential biosignature is the polarized glint of a liquid ocean. Light reflecting off a smooth liquid surface becomes polarized in a specific way. Detecting a periodic change in polarized light as the planet rotates could be a way to confirm the presence of vast, open bodies of liquid on the surface, directly seeing the glint of an alien sea. Beyond the primary biosignatures of oxygen and methane, our search for life on this second Earth will venture into the realm of more subtle, secondary indicators. One such marker could be the presence of complex, synthetic-appearing molecules in the upper atmosphere. On Earth, industrial activity has released chlorofluorocarbons, CFCs, gases so artificial they are an unmistakable sign of technology. While we would not expect to find our specific pollutants, an advanced civilization might produce its own unique set of industrial byproduct gases. The James Webb Space Telescope or its successors could potentially detect the spectral fingerprints of these complex non-biogenic molecules. Finding such a technosignature would be even more profound than finding a biosignature. It would not only tell us that life exists, but that intelligence has arisen, harnessed energy, and altered its world on a planetary scale. It would be an eerie, indirect conversation across the light years. A message not intended for us, but one we learn to read in the chemical composition of the air itself, telling a silent story of another's industry and technological journey. The very tectonics of this world would dictate its long-term habitability. On Earth, plate tectonics act as a global thermostat. Volcanic activity releases carbon dioxide into the atmosphere, warming the planet, while the weathering of silicate rocks on the surface draws CO2 out of the atmosphere, cooling it. This carbon-silicate cycle has kept Earth's climate relatively stable for billions of years. A tidally locked super-Earth might not have plate tectonics in the same way. Instead, it might have what is known as stagnant lid tectonics with a thick, immobile crust. In this case, long-term climate regulation would depend heavily on heat pipe volcanism, where magma erupts directly through the crust at fixed hotspots. These hotspots would likely be concentrated on the scorching day side or the stressed terminator zone. The viability of the planet over geologic time would hinge on whether this different style of volcanism could regulate the atmospheric CO2 levels with the same life-sustaining precision as Earth's more dynamic system. The planet's ability to breathe geologically is as important as any biological process. We must consider the water world hypothesis for our candidate. If the planet formed in a region of its solar system rich in water ice, it might not have distinct continents and oceans like Earth. Instead, it could be entirely covered by a single, global ocean, perhaps hundreds of kilometers deep. In this scenario, there would be no rock weathering on the surface to draw down CO2, making climate regulation difficult. Life could still exist, thriving in the vast liquid expanse, but it would be purely marine. The deepest layers of such an ocean would be a realm of unimaginable pressure, where water itself transforms into exotic forms of high-pressure ice, such as Ice 7 or Ice X, even at warm temperatures. This would create a floor to the ocean made of ice, cutting off the water from the rocky mantle below. This would prevent the chemical exchanges that are thought to be crucial for the origin of life. Therefore, the ideal second Earth may not be a water world, but a world with a balanced inventory of water, one with shallow seas and large continents, allowing for the full, complex interplay of geology, hydrology, and biology. The stability of this potential paradise is not guaranteed by its star alone. It is also a function of its planetary siblings. The architecture of a solar system plays a crucial role in the fate of its habitable worlds. A massive gas giant in a distant, stable orbit, like Jupiter in our system, can act as a cosmic bodyguard, gravitationally deflecting many comets and asteroids from the inner solar system. However, if a gas giant were in a closer, eccentric orbit, it could wreak havoc, flinging debris inwards or destabilizing the orbit of the habitable planet itself, potentially casting it into its star or out into interstellar space. The radial velocity measurements used to find our candidate planet can also reveal the presence of other, more massive planets in the same system. A quiet system, with any gas giants remaining in orderly distant orbits, is another checkmark on the long list of conditions required. The silent, gravitational dance of all the planets in this system must be a graceful ballet, not a chaotic mosh pit, for the habitable world to have survived for the billions of years necessary for life to flourish. We often assume a tidally locked planet has zero axial tilt, its equator perfectly aligned with its orbital plane. But what if it has a tilt similar to Earth's 23.5 degrees? This would introduce a fascinating new type of seasonality. The motionless red sun would no longer hang fixed at the horizon of the terminator. Instead, over the course of the planet's year, it would appear to slowly drift up and down in the sky. For an observer in the northern hemisphere of the terminator zone, the sun would rise higher for half the year, bringing warmer temperatures, and sink lower for the other half, bringing a cooler period. This would create a gentle, predictable seasonal cycle in the most valuable real estate in the system. This nodding of the planet would also mean that the polar regions, which would otherwise be in permanent darkness, would experience periods of faint seasonal sunlight, perhaps enough to melt some of the ice and create temporary high-latitude habitable zones. An axial tilt could therefore dramatically increase the surface area and temporal stability of the habitable regions, making the world an even more robust and promising candidate for life. The theory of lithopanspermia suggests that life may not need to originate on every habitable world, but can be transported between them. If a large asteroid or comet strikes a planet that hosts life, the impact can eject rocks into space with enough force to escape the planet's gravity. If these rocks contain hardy microorganisms, they could be shielded from the vacuum and radiation of space within the rock's interior, entering a state of suspended animation. Then, over thousands or millions of years, these life-bearing meteorites could drift through the solar system and eventually land on another habitable world, seeding it with life. In the context of our candidate system, if an adjacent planet, perhaps one that was habitable early in its history but has since lost its water, had developed life first, it could have seeded our second Earth. This would mean that finding life there might not represent a second, independent genesis, but a single origin event that spread throughout its local system. It complicates our search for a second life, but also presents the incredible possibility of a single solar system hosting a related but separately evolved family of biospheres. The surface chemistry of a world is profoundly influenced by a constant rain of high-energy particles from space known as cosmic rays. When these particles, mostly protons and helium nuclei, strike the atoms in a planet's atmosphere or soil, they can trigger nuclear reactions, a process called cosmic ray spallation. This process can create rare elements and isotopes, like beryllium-10 or carbon-14. On a tidally locked world with a potentially weaker or differently configured magnetic field, the surface might be exposed to a higher flux of these cosmic rays. This could alter the chemical environment in significant ways, perhaps breaking down complex organic molecules on the surface, making it more sterile. Conversely, this energy input could also act as a catalyst for novel chemical reactions, potentially creating precursor molecules for life that wouldn't form otherwise. The study of this planet's regolith and atmospheric composition would have to account for this constant cosmic bombardment. It is another reminder that a planet is not a closed system, but but is in a constant dynamic interchange with its galactic environment, being shaped by forces that originate from supernova explosions thousands of light-years away. The long-term stability of a planet's orbit can be secured by a phenomenon known as orbital resonance. This occurs when two or more orbiting bodies exert a regular, periodic gravitational influence on each other, often in a simple integer ratio of their orbital periods. For example, for every one orbit a planet makes, its neighbor might make exactly two. This resonant relationship can prevent orbits from becoming chaotic over time, locking planets into a predictable, stable configuration. In our candidate system, observing such a resonance with its neighboring planets would be a very positive sign. It would suggest that the system has settled into a mature, stable state and is likely to remain that way for billions of years to come. It would be evidence of a kind of cosmic order, a self-organizing principle in the gravitational dynamics of the system. Finding our second Earth not just in the right place, but also locked in a harmonious gravitational rhythm with its family of planets, would add another layer of confidence that we have found a world that is not just habitable now, but has been and will be for a very long time. The sand on an alien world would tell a story. The size, shape, and composition of sand grains are a direct result of a planet's geology and weather. On Earth, our sand is predominantly quartz, a hard, resistant mineral. On a world with different rock types, sand could be made of dark volcanic basalt, green olivine, or even gypsum, creating beaches of black, green, or white. The wind on a tidally locked world, being persistently unidirectional, would create dunes of a different character than on Earth. Instead of shifting, variable dune fields, we might expect to find colossal, elongated, longitudinal dunes, stretching for hundreds of kilometers in the direction of the wind, permanent features of the landscape. Studying the shape of these dunes from orbit could tell us about the strength and consistency of the wind, while analyzing the composition of the sand would reveal the parent rock from which it eroded. The simple act of sifting alien sand through a robotic hand would be a profound moment of geological connection, a way of reading the planet's history in its smallest, most granular details. The photochemistry of the upper atmosphere would be a unique chemical laboratory. Photochemistry is the study of chemical reactions driven by the energy of light. On Earth, high-energy ultraviolet photons from our sun drive reactions like the formation and destruction of ozone. On our candidate world, the light from the red dwarf is poor in UV but rich in red and infrared photons. This would lead to a completely different set of photochemical reactions. Perhaps certain molecules, which are stable in our atmosphere, would be readily broken apart by the intense infrared radiation. This could lead to the formation of exotic haze layers or clouds made of compounds unfamiliar to us. These haze layers could play a huge role in the planet's climate, either by reflecting light back into space and cooling the planet, or by absorbing it and warming it. Understanding this alien photochemistry is essential for accurately interpreting the planet's atmospheric spectrum. The sky's chemistry is a direct conversation with its star, a reaction to the specific colors and energies of light it receives. The first priority for any long-term settlement would be a reliable, large-scale power source. A tidally locked world offers two tantalizingly obvious yet challenging options. The first is geothermal energy. The intense geological stresses along the Terminator Zone would likely create numerous volcanic vents and geothermal hotspots. Tapping into this direct heat from the planet's core would provide a constant, stable, and highly efficient source of power, independent of the star. The second option is solar power on a colossal scale. The permanent day side of the planet receives an uninterrupted stream of stellar energy. One can imagine vast solar farms, covering thousands of square kilometers of the scorched inner desert, soaking up the red light of the star. This energy could then be transmitted via superconducting cables or beamed via microwave to the settlements in the Terminator Zone. Most likely, a mature colony would use a hybrid approach, relying on the stability of geothermal for baseline power and the immense potential of solar for energy-intensive industrial processes. Harnessing the planet's innate energy from its hot core to its star's constant gaze would be the first great engineering feat of the new civilization. Establishing a robust communications and observation network around the new world would be essential. This would likely take the form of a constellation of satellites in various orbits. Some, in a high orbit, would act as communication relays, ensuring that colonists on opposite sides of a mountain range or on an exploratory mission could remain in contact. Others, in low orbits, would be dedicated to planetary science, continuously monitoring the weather, mapping the surface in high resolution, and watching for the telltale signs of stellar flares from the parent star. This flare detection system would be crucial, providing an early warning that would allow colonists to take shelter and protect sensitive electronics. Building, launching, and maintaining this satellite network using local resources would be a major technological goal for the colony. It would represent the creation of a planetary-scale nervous system, an extension of the colonists' senses that would allow them to understand, predict, and ultimately live in harmony with the complex and sometimes violent rhythms of their new home. We must consider the psychology of a fixed horizon. On Earth, the rising and setting of the sun is our most fundamental clock, a rhythm that defines our sense of passage and renewal. On a tidally locked world, this would be absent. The crimson sun would be a permanent fixture in the sky, and the landscape's shadows would never move. This could have a deeply disorienting effect on the human psyche. The sense of time's passage might become muted, leading to a kind of psychological stagnation. The colonists might develop a very different relationship with their landscape, seeing it not as a dynamic, changing entity, but as a static, eternal sculpture. This could foster a powerful sense of place and belonging, but also perhaps a feeling of being trapped. The unchanging nature of the view could become a source of comfort for some, and a source of profound existential dread for others. The architecture of the colony might even be designed to counteract this, with interior spaces that have dynamic lighting systems to simulate a day-night cycle, providing a familiar rhythm in a world that has none. Language evolves to reflect the environment of its speakers. The colonists on this second Earth, and especially their children, would inevitably develop their own dialect, and eventually a new language. They would need words for concepts that are meaningless on Earth. What do you call the direction toward the sun side, or the direction toward the dark side? These would be as fundamental as north and south are to us. They would need a rich vocabulary to describe the different qualities of the perpetual twilight, the various types of black flora, and the unique weather phenomena. The language would be peppered with terms born from their unique technological and survival challenges. The very grammar might shift to reflect a different perception of time, perhaps with less emphasis on past, present, and future tenses, and more on continuous or cyclical states of being. Listening to the speech of a colonist a few centuries after settlement would be like hearing a living fossil record of humanity's adaptation to a new reality, a story told in phonemes and syntax. The first art created on a new world would be a profound expression of the human encounter with the alien. What would a painter, faced with a palette of crimsons, oranges, and deep purples, create on their canvas? The subject would not be fleeting sunsets, but the permanent, sublime glow of the Terminator. Sculptors might use the strange alien rock with its unique colors and textures to create forms that reflect the vast, static landscapes. The music might be ambient and cyclical, mirroring the endless wind and the lack of a day-night rhythm, perhaps using the low-frequency rumbles of the planet's geology as a foundational drone. It would be an art of stillness, of eternity, of deep time. This art would be more than decoration. It would be a crucial tool for processing and understanding the new environment, a way to find beauty and meaning in a world that is so fundamentally different from the one that birthed our species. It would be the beginning of a completely new cultural lineage, the first chapter in the art history of another world. The question of governance on a new world would be a chance to reboot human political philosophy. Far from the influence and history of Earth's nations, the colonists would have to forge a new social contract. Would they base their laws on historical precedent from Earth, or would they attempt something radically new? The small, interdependent nature of the early colony would demand a high degree of cooperation, perhaps favoring a more collectivist or consensus-based model of decision-making. How would they handle property? On a world that is, for all intents and purposes, infinite in its resources and land, the very concept of private land ownership might seem absurd. Perhaps they would adopt a system where land is held in common, for the benefit of all. The founding charter of this new society would be one of the most important documents they could write, an attempt to learn from all of human history's political failures and successes to create a more just, stable, and resilient society, designed from first principles for life on another planet. Sooner or later, the colonists would face the ultimate engineering question: should they terraform the planet? The idea is seductive. With sufficiently advanced technology, could they spin the planet up to create a day-night cycle? Could they engineer the atmosphere to make it breathable without a suit, or to create a blue sky? Could they transport water from the night side to create new seas? This endeavor would take millennia and an unimaginable amount of energy, but it represents the ultimate expression of human mastery over nature. However, it also raises profound ethical questions. If the planet has its own native life, even if it's only microbial, do we have the right to destroy an entire biosphere to make the world more comfortable for ourselves? This is the prime directive problem in its starkest form. Perhaps the more ethical and wiser path would be not to change the planet to suit us, but to change ourselves to suit the planet, adapting our technology and biology to live within the world's natural systems, becoming a part of its alien nature rather than its conqueror. The immense complexity of managing a colonial biosphere and exploring a new world would likely be impossible without the aid of highly advanced artificial intelligence. An AI could serve as the central nervous system of the colony, monitoring life support systems, managing power distribution, and optimizing agricultural yields with a level of efficiency no human group could match. It could pilot robotic rovers and drones, exploring hazardous regions of the planet and collecting vast amounts of data for human scientists to analyze. It could serve as a repository of all human knowledge, an incorruptible library and advisor for the colonists. The relationship between the humans and this colonial AI would be one of deep symbiosis. The AI would handle the immense computational load of survival, freeing up the humans to focus on research, creativity, and the larger strategic decisions. In this sense, the first successful off-world colony might not be purely human, but a hybrid human-AI civilization, a partnership between biological and artificial consciousness, taking its first steps into the galaxy together. The biological challenge of a new world is a two-sided coin. On one hand, the planet may be perfectly sterile, meaning colonists would not face the threat of alien pathogens. However, the human immune system has evolved in a constant arms race with Earth's microbes. In a sterile environment, it might become complacent or overreactive, leading to autoimmune disorders. The colonists' gut microbiome, essential for digestion and health, would have to be carefully maintained and curated. On the other hand, the planet might not be sterile. It could host its own microbial life. While the chances of an alien microbe being pathogenic to humans are low, due to a completely different biochemistry, it is not zero. A simple alien bacterium could be toxic to human cells, or it could consume a vital nutrient that our bodies cannot live without. The first biological samples returned from the surface would be handled with the most extreme caution, analyzed in sealed labs to assess any potential threat. The first handshake between Earth life and alien life would happen at the microscopic level, and its outcome would determine the future of the colony. Every culture is built upon a foundation of mythology, a shared story that explains where we come from and why we are here. The colonists of a new world would create their own. Their origin myth would be the story of Earth, the blue ghost, the ancestral paradise that they had to leave. The journey on the starship would become their great crossing, an epic tale of endurance and hope. The first landing would be their Genesis Day, a sacred moment in their history. These stories would be told to their children, shaping their identity. They would look up at the star-filled sky and see Earth not just as a point of light, but as the home of their ancestors, a place of legend. This new mythology would be unique in human history because it would be entirely true, based on recorded events. Yet, over the centuries, it would acquire the same mythic power as the stories of old, providing a sense of purpose and a shared cultural narrative that would bind the new society together as they faced the challenges of their permanent, beautiful, and alien home. Preserving the legacy of Earth would be a sacred trust for the colonists. They would carry with them a digital archive of immense scale, a new library of Alexandria containing all of humanity's art, literature, music, science, and history. This archive would be their most precious cargo. But how to preserve it for thousands of years in a new environment? Digital data can degrade. They would need incredibly robust long-term storage solutions, perhaps data etched into quartz crystals or encoded in synthetic DNA. The library would have multiple, redundant backups stored in secure, geologically stable locations around the planet. The education of the young would revolve around this archive, ensuring that the lessons and beauty of Earth's long and often troubled history are not forgotten. The colonists would be not just pioneers but also librarians and archivists, carrying the cultural DNA of their homeworld with them, ensuring that the wisdom of Socrates, the music of Bach, and the art of Van Gogh would have a home and an audience under the light of a distant alien sun. The economy of a fledgling colony would be fundamentally different from any on Earth. In the early stages, it would be a, quote, scarcity economy in some ways and a total scarcity economy in others. Raw materials like rock, water, and atmospheric gases would be virtually unlimited. However, highly complex manufactured goods, like computer chips or medical equipment, would be incredibly scarce and valuable, at least until the colony could replicate the entire industrial base of Earth. The primary currency would not be money, but something more fundamental: energy, measured in kilowatt hours, or perhaps even time and specialized labor. A person's wealth might be measured by their skills and their contribution to the community's survival and progress. There would be no stock market, no consumerism as we know it. The economy would be a closed-loop system, entirely focused on sustainability, growth, and the efficient allocation of resources to solve mission-critical problems. It would be an economy of pure function and purpose, a direct reflection of the colony's core identity as a survival and exploration enterprise. The education of the first native-born generation would be a unique pedagogical challenge. Their curriculum would be a blend of the practical and the profound. On one hand, every child would need to learn the basics of physics, engineering, biology, and computer science, as their lives would depend on maintaining the colony's complex technology. They would learn how to farm in biodomes, how to repair a life support system, and how to read the alien sky. On the other hand, their humanities education would be equally important. They would study the history of Earth to understand their origins, its philosophies to grapple with the meaning of their new existence, and its arts to connect with their emotional heritage. Their history lessons would start with the Big Bang, move through the evolution of life on Earth, the rise of human civilization, the Great Journey, and culminate in their own existence. They would be raised with a cosmic perspective as their default setting, seeing themselves as part of a story that is billions of years old and spans light years of space. Even in a high-tech survival-focused colony, humanity's innate need for play and recreation would find new expression. Sports would be adapted to the new gravity. On a higher gravity world, feats of leaping and acrobatics would be more difficult, perhaps leading to sports that emphasize strength and strategy. On a lower gravity world, the opposite would be true. Sports involving graceful, three-dimensional movement, like a hybrid of gymnastics and basketball in a large, open dome, could become popular. Exploratory hiking and mountaineering in the Terminator Zone's landscapes would be a common pastime, albeit one requiring protective suits and careful planning. Entertainment would blend the virtual and the real. Immersive virtual reality experiences could allow colonists to visit a simulated Earth, while new forms of art and music, as we have discussed, would provide a unique cultural outlet. This development of a new recreational culture would be a key sign of the colony's success, a signal that they have moved beyond mere survival and are now truly living. We must soberly acknowledge that a new society would not be a utopia. Human nature, with its flaws and conflicts, would make the journey with them. The first crime committed on another world would be a grim but significant milestone. How would the colony's fledgling legal system respond? With no prisons in the early days, and with every individual's labor being critical to the colony's survival, punishments like incarceration would be impractical. Justice might take the form of restorative practices, mediation, or perhaps temporary exile from the main habitat to a more isolated outpost. The challenge would be to create a system of justice that is effective and fair, but also recognizes the unique, high-stakes environment of the colony. The resolution of this first conflict would set a precedent for the rule of law on a new world, a test of whether the carefully constructed social contract could withstand the friction of real human behavior so far from home. The discovery of a viable second Earth would force us to confront the Great Filter theory with new urgency. This theory posits that there is some great barrier to the emergence of a widespread, spacefaring civilization, which is why we see no evidence of them. The question is, where is this filter? Is it behind us, meaning the emergence of life or intelligence is incredibly rare? Or is it ahead of us, meaning that civilizations tend to destroy themselves before they can colonize the galaxy? Finding a world that is clearly habitable, and perhaps even teeming with simple life, would be a deeply unsettling discovery in this context. It would suggest that the early filters, the origin of life, the evolution of complex cells, are not that difficult to pass. It would lend weight to the terrifying possibility that the Great Filter lies ahead of us, in the form of nuclear war, ecological collapse, or the dangers of advanced technology. Our candidate planet, in its promising silence, might be a warning that the most difficult test for a civilization is not finding a new home, but learning to survive on its first one. The anthropic principle provides another lens through which to view this discovery. In its weak form, it states that our observations of the universe are biased by the very fact of our existence as observers. We find ourselves in a universe that is hospitable to life, and on a planet that is hospitable to life because if we were anywhere else, we wouldn't be here to observe it. It's a selection bias. The discovery of a second Earth-like planet might seem to challenge this, suggesting that habitable worlds are common. However, even if there are billions of them, we could only ever have originated on one of the ones that successfully fostered intelligence. The discovery doesn't necessarily mean such worlds are common, only that there is at least one other besides our own within our observational reach. It's a subtle but profound philosophical point. We are a part of the universe observing itself, and our existence preconditions what we can see. This new world is not just a piece of data, it is a reflection of the conditions that allowed for our own consciousness to arise and ask these questions in the first place. The concept of the galactic habitable zone is a scaling up of the circumstellar version. It proposes that even within a galaxy, some regions are more suitable for life than others. The galactic core is a violent place, with intense radiation from a central supermassive black hole and a high rate of nearby supernovae that would sterilize any nascent life. The outer fringes of the galaxy, conversely, may be too poor in the heavy elements necessary to form rocky planets and life itself. The sweet spot is a ring partway out from the center, where the conditions are just right. Both our Sun and the star of our candidate planet would need to reside within this galactic Goldilocks zone. Verifying that this new system is also in this privileged region would add another layer of cosmic significance. It would suggest that there is a vast, stable suburbia in the Milky Way where the conditions for life have been ripe for billions of years, a fertile crescent on a galactic scale, and we may have just found our nearest neighbor within it. This planet, with its potentially immense age, is a geological and biological time capsule. Its oldest rocks could be billions of years older than Earth's, holding a record of the galaxy's chemical composition in a much earlier epoch. By analyzing these ancient stones, we could learn about the types of stars that were common then, the frequency of supernovae, and the elemental building blocks available for planet formation in the early Milky Way. If life exists there, its genetic code could be a living fossil. It could show us what the earliest forms of life were like, perhaps revealing a simpler, more primitive version of the DNA or RNA system we see on Earth. It would be a window into the deep past, allowing us to test our theories about abiogenesis and the early evolution of life. This world is not just a potential future home. It is a museum of cosmic history, its rocks and potential life forms holding the secrets of a past so remote that all physical evidence of it on Earth has long been erased by tectonics and erosion. There is no better way to appreciate the unique miracle of our own biosphere than to study the potential of another. Every parameter we consider for this second Earth, its atmospheric pressure, its gravity, its stars' radiation, its geochemistry, forces us to look back at our own world with new eyes. We suddenly see the Earth not as a static backdrop, but as a breathtakingly complex and interconnected system, a dynamic equilibrium of countless variables that have been fine-tuned over 4.5 billion years to create the only home we have ever known. The deep blue of our oceans, the precise oxygen content of our air, the protective shield of our magnetic field, the dance of our plate tectonics, we see them not as givens, but as precious and perhaps rare contingencies. The search for another habitable world, therefore, becomes an act of profound self-reflection. It fosters a deeper ecological consciousness, a sense of awe and responsibility for the intricate, living machine that is our own planet. To look for home elsewhere is to truly see it for the first time. Consciousness may not be a fluke, but an emergent property of complex information processing systems, a phenomenon the universe strives to create. If this is true, then every habitable world is a potential crucible for consciousness, another opportunity for the universe to wake up and become aware of itself. This second Earth, in this philosophical light, becomes more than just a piece of real estate. It is a sacred ground, a place where another lineage of thought, of feeling, of wonder may have arisen. The silence we perceive from it could be the silence of a pristine world waiting for a mind to appreciate it, or it could be the silence of a mind so different from our own that we cannot recognize its transmissions. The moral weight of our interaction with this world is therefore immense. If we are the first consciousness to arrive, we have a duty of stewardship. If we are the second, we have a duty of respect and caution. The discovery elevates our own existence from a singular, isolated event to being a potential participant in a galactic community of minds. Let us project our minds forward 10,000 years into the future. How will this moment, this discovery, be remembered? It will likely be seen as a turning point in the human story, as significant as the discovery of fire or the invention of writing. It would mark the end of our planetary childhood and the beginning of our maturity as a species. Our descendants, whether they live on a restored and vibrant Earth or on the settlements of this new world, will look back on this era as the time when the walls of the cradle were finally breached, when the true, vast scale of our home was revealed. The names of the scientists who made the discovery, the telescopes they used, the first images they saw, these will be the foundational elements of a new history, a history that is not just human, but cosmic. This discovery is a legacy we are creating for the future, a gift of perspective and hope. It is a declaration that even in times of trouble, we did not stop looking up, we did not stop questioning, and we did not stop dreaming of what lies beyond the horizon. The discovery of a potentially living world is the ultimate test of our cosmic loneliness. For all of human history, we have been fundamentally alone, a single species on a single planet, the only known example of life and intelligence. This solitude has shaped our religions, our philosophies, and our sense of self. It is the baseline of our existence. The confirmation of a biosphere on another world, even a microbial one, would shatter that solitude forever. We would know, definitively, that the universe is not sterile, that the spark of life is not a one-time miracle. The emotional and philosophical impact would be staggering. We would be members of a cosmic family, even if we are separated by an impassable gulf. The universe would suddenly feel less empty, less vast and indifferent. It would feel more like a garden, with life sprouting in different corners, and our own existence would feel less like a random accident and more like a natural, expected outcome of a creative and life-giving cosmos. Contemplate the flow of time on this ancient world. While our ancestors were learning to chip stone tools, this planet was already billions of years old, its crimson sun bathing it in a steady, quiet light. While empires rose and fell on Earth, this world's terminator winds blew uninterrupted, eroding mountains grain by grain. It has been waiting in the darkness, following the silent, elegant laws of orbital mechanics for a span of time that makes all of human history seem like the blink of an eye. There is a profound meditative quality to this realization. It connects us to a sense of deep time, humbling our own urgent concerns and placing them in a cosmic context. We are not the first or only story. We are a brief, recent event in a universe that is ancient and patient. This planet's existence is a silent testament to the long, slow, creative processes of the cosmos, a story written in geology and gravity, and we have only just arrived in time to read its first page. There is an inherent beauty in the mathematical certainty that governs this world's existence. The law of universal gravitation, articulated by Newton, dictates its orbit with unerring precision. The laws of thermodynamics govern the flow of heat from its day side to its night side. The laws of quantum mechanics determine the specific wavelengths of light its star emits and its atmosphere absorbs. This planet is a symphony of physical law, a place where abstract mathematical principles manifest as a physical, tangible reality. Finding it, and understanding its properties, is a celebration of the human mind's ability to comprehend these fundamental laws. It validates the scientific method, our most powerful tool for having a conversation with the universe. The world is not just a collection of rock and gas. It is an embodiment of cosmic order, a testament to the elegant, rational structure of the reality we inhabit, a structure that is not only powerful, but also capable of producing places of profound and serene beauty. The quest for a second Earth can be seen as a modern manifestation of the heroic journeys of ancient mythology. It is a quest for a distant prize, a holy grail of cosmic significance. It requires immense effort, incredible technology, and a belief in a goal that may not be reached for generations. The scientists are the navigators, the engineers are the shipbuilders, and the telescopes are our vessels. The journey is fraught with peril, the vast distances, the technical challenges, the possibility of failure. But the potential reward is transformative. A new world, a new beginning, a new understanding of our place in the universe. This narrative is deeply resonant with the human spirit. We are a species that has always been driven by stories of exploration and discovery, of venturing into the unknown to bring back knowledge and wonder. The search for this planet is the latest and grandest chapter in that epic story, a scientific quest with the emotional weight and power of a spiritual pilgrimage. This planet serves as a perfect Rosetta Stone for planetary science. On Earth, we have only one data point for a habitable living world: Earth itself. This makes it difficult to know which of our planet's features are essential for life and which are merely incidental. The discovery of a second, potentially habitable world, even one as different as a tidally locked planet around a red dwarf, gives us a crucial second data point for comparison. By studying its similarities and its differences, we can begin to untangle the complex web of variables that lead to habitability. Is a strong magnetic field essential, or can a thick atmosphere compensate? Are plate tectonics necessary, or can another geological system regulate the climate? This planet allows us to test our models of planet formation and climate science in a new laboratory. It is a key that could unlock a more universal understanding of how habitable worlds form and evolve throughout the galaxy. The universe is in a constant state of creation and destruction, a cyclical dance of matter and energy. The discovery of this world is a snapshot of one moment in that dance. It formed from the debris of previous generations of stars, stars that lived, created heavy elements in their cores, and then died in spectacular supernova explosions. These elements then coalesced into a new star and a new family of planets. This process is happening right now in the nebulae of our galaxy, and it will continue long after our sun has died. Our candidate planet is a beautiful example of this cosmic recycling. It reminds us that we are part of a process that is much larger and older than ourselves. We and this planet are made of stardust, temporary configurations of ancient matter that has been repurposed by the cosmos. There is a deep comfort in this continuity, a sense of being part of an unending creative cycle. One of the most poetic and humbling aspects of this red dwarf system is its sheer longevity. Our sun will exhaust its fuel in another 5 billion years, swelling into a red giant that will sterilize and likely consume the Earth. But the red dwarf, burning its fuel so frugally, will continue to shine for trillions of years. Its habitable planet could remain a stable abode for life long after Earth is gone, long after the Andromeda galaxy has merged with our own, long after many of the familiar constellations have drifted apart. If life exists there, or if we plant it there, it has a potential future that is thousands of times longer than our own planets. It could be one of the last bastions of life in an aging, darkening universe. This thought places our own existence in a profound perspective. We are a fleeting moment of warmth and light. This other world, this second Earth, represents a chance for the legacy of life to be passed on to a future so remote and long-lasting that it defies our imagination. The final analysis of this world will ultimately depend on our ability to capture its light directly. While transit spectroscopy is powerful, the ultimate goal is direct imaging, creating an actual photograph of the planet, separate from the light of its star. This is an immense technological challenge, as the planet is billions of times fainter than its star and incredibly close to it. It requires advanced space-based telescopes with powerful coronagraphs to block the starlight, and complex adaptive optics to correct for any distortions. But if we succeed, the reward would be historic. We would see it not as a wobble or a dip in the light, but as a tiny, faint dot. We could then analyze the color of that dot to infer the presence of clouds, oceans, or continents. We could watch it over time to see changes in its weather. It would be a, quote, pale red dot, a companion to Carl Sagan's famous pale blue dot image of Earth. That single, pixelated image would be a testament to our ingenuity and the definitive proof that new worlds await us in the cosmic dark. The dream of visiting this world in person may be centuries away, but a precursor mission is conceivable within our lifetime. This is the concept of a star wisp or nanoprobe, championed by projects like Breakthrough Starshot. The idea is to create a tiny, gram-scale robotic probe, essentially a computer chip with a camera and sensors, and attach it to an ultralight solar sail. A powerful array of Earth-based lasers would then focus a beam of light on the sail, accelerating it to a significant fraction of the speed of light, perhaps 20%. At this incredible velocity, the probe could cross the interstellar distance to our candidate planet in a matter of decades, rather than millennia. It would not stop, but would fly through the system at high speed, capturing as much data and as many images as it could in a few frantic hours. This data would then be beamed back to Earth. It would be a fleeting, one-way reconnaissance, but it would be our first physical touch, a messenger from home, sent to scout the trail for the generations that will follow. Every photon captured from this distant solar system is a form of first contact. It is not the dramatic encounter with alien beings of science fiction, but a more subtle, more profound kind of communication. The universe is speaking to us in the language of physics. The light from the star tells us its temperature and age. The shadow of the planet tells us its size and orbit. The spectrum of its atmosphere tells us its chemical composition and hints at its potential for life. We are, through the scientific method, learning to translate this language. Each new discovery, each refined measurement, is another sentence in a long, ongoing conversation. This planet is teaching us about itself, about the processes that create worlds, and about the prevalence of habitable conditions in the galaxy. This form of contact is quieter, but in many ways more meaningful. It is not a story someone is telling us, but the raw truth of reality, which we are slowly, patiently learning to read for ourselves. This entire endeavor is fueled by a uniquely human quality: restless, insatiable curiosity. We are a species that cannot stop asking what if, and what's over there. It is this drive that pushed our ancestors out of Africa to populate the globe, that pushed them across oceans to discover new continents, and that pushed them to leave the atmosphere and walk on the moon. The search for a second Earth is the modern expression of this same ancient impulse. It is exploration for its own sake, for the sheer joy of discovery and the expansion of knowledge. It is not driven by a need for immediate profit or practical application, but by a deep-seated need to understand our universe and our place within it. This curiosity is our greatest strength. It is the engine of our science and the wellspring of our art. It is the quality that will, if anything can, eventually carry us from our homeworld to the shores of another. The planet represents a tangible focal point for our collective hope. In a world often divided by conflict and consumed by short-term problems, the quest for another Earth offers a unifying vision for all humanity. It is a project that belongs to no single nation or ideology, but to our entire species. The challenges are so immense that they would require unprecedented international cooperation, a pooling of our scientific, engineering, and financial resources. Working together to reach for the stars could be the very thing that helps us to better manage our affairs here on Earth. It gives us a shared goal, a common dream, a positive vision of a future where humanity is not just a survivor, but a curious and peaceful explorer. This world, in its distant silence, beckons to the best part of our nature, calling on us to rise above our divisions and work together as a single people, Earthlings, dreaming of a new sky. Ultimately, the story of this planet is a story of potential. It is a canvas upon which we project our greatest hopes and our deepest fears. It could be a pristine, living paradise or a sterile, irradiated rock. It could host an ancient, wise civilization or the ruins of one that failed. It could be our future home, or a tantalizing dream that is forever out of reach. For now, it exists in a quantum state of possibility in our minds, all of these things at once. The beauty of the scientific process is that it allows us to slowly, carefully collapse that wave of possibilities into a single observed reality. But until that day comes, the planet serves its most important purpose right now. It is a mirror. It shows us not what is out there, but what is inside us. It reflects our capacity for wonder, our drive to explore, our fear of loneliness, and our unending hope for a future filled with discovery. Let's reconsider the wind. This constant planet-wide circulation of air from the hot side to the cold side would be the most dominant environmental factor. But it wouldn't be uniform. As the wind travels over oceans, it would pick up moisture. As it flows over mountain ranges, it would create complex turbulence and rain shadows. This would result in a mosaic of microclimates within the larger terminator zone. There could be perpetually wet, misty rainforests on the windward side of mountains and arid, dry plains on the leeward side. There could be vast, humid swamps where rivers slow and pool, and cool, breezy coastlines along the ring ocean. A colonist could travel a few hundred kilometers and experience a completely different environment, despite the sun's position in the sky never changing. The landscape would have a permanent weather grain to it, with ecosystems arranged in long, linear bands, all aligned with the direction of the ceaseless, life-giving, planet-shaping wind. The chemical senses, smell and taste, would be in for a universe of novelty. The air, filtered through an alien biosphere and over alien geology, would carry scents for which we have no name. What does a forest of black, infrared photosynthesizing plants smell like? What is the aroma of rain falling on soil rich in copper instead of iron? The water itself might have a different taste, depending on its mineral content. Any native fruits or edible life would present a palette of flavors utterly foreign to our experience, the product of a completely separate evolutionary history. The first explorers would have to rely on chemical sensors to determine what is safe, but eventually, their descendants would develop a native sensory map of the world. They would be able to smell the approach of a distant rainstorm or identify a plant by its fragrance. This intimate, chemical understanding of the world is a deep part of what it means to be at home in a landscape. The idea of planetary protection works both ways. While we must be vigilant to avoid contaminating this new world with Earth microbes, we must be equally careful not to bring anything dangerous back. Any samples returned to Earth, rocks, ice, or atmospheric gases would be treated as potentially biohazardous in the extreme. They would be studied in the highest-level biosafety labs, like the BSL-4 facilities used for the most dangerous viruses on Earth, but likely in a dedicated facility in high Earth orbit or on the Moon to ensure there is no chance of an accidental release into our own biosphere. An alien microbe, even if not a pathogen, could be a devastating invasive species, outcompeting Earth life for a key resource and unraveling our finely balanced ecosystems. The first contact, therefore, requires a double quarantine of unprecedented rigor. The stakes are not just the health of a few astronauts, but the biological integrity of an entire planet, or two. Let your mind drift now, away from the technical details and into the pure feeling of the place. Imagine yourself standing on a high ridge in the terminator zone. The ground beneath your feet is a deep, reddish-brown rock. Below you, a valley is filled with a forest of foliage so dark it is almost black, punctuated by the soft blue-green glow of bioluminescent fungi. The air is cool, and a steady, gentle wind, blowing from your right to your left, makes a low hum as it passes through the alien trees. At the horizon to your right, the colossal, dim, crimson sun is a permanent, beautiful fixture. To your left, the sky darkens to a deep indigo, where the bright, unfamiliar stars are already visible. And stretching across the entire sky is the magnificent, blazing river of the Milky Way, more vivid and detailed than any human has ever seen it from Earth. There is no sound of birds or insects. There is only the wind and the profound, peaceful, and eternal silence of a world waiting. This is where our journey, for now, must pause. We have traveled from the initial detection of a shadow crossing a star, to the detailed imaginings of an entire world. We have explored its science, its challenges, and its profound philosophical implications. The planet has transformed from a single data point into a rich and complex character in the human story. It remains a world of pure potential, a cosmic question mark. But the very act of asking the question has enriched us. It has pushed the boundaries of our science and expanded the horizons of our imagination. The planet is a beacon, reminding us that the universe is far grander and more wondrous than we yet know. It calls to us across the void, not with a voice, but with the steady, patient light of gravity and chemistry, inviting us to continue the search, to keep looking up, and to never lose our capacity for awe in the face of the magnificent, silent cosmos. The very architecture of life on this world might be built from a different set of molecular Legos. While Earth life is homochiral, using exclusively left-handed amino acids and right-handed sugars, there is no fundamental physical reason for this preference. It was likely a frozen accident, a random choice made at the dawn of life. On this second Earth, life could have made the opposite choice, resulting in a mirror biosphere of right-handed amino acids and left-handed sugars. To us, the planet would look lush and inviting, but its biology would be fundamentally indigestible and potentially toxic. An astronaut could starve to death in a field of what appears to be edible fruit. This concept of mirror life is a stark reminder of the subtle, contingent nature of our own biology. It would mean that even if we find a second Garden of Eden, we may be forever separated from it by an invisible molecular barrier, unable to partake in its bounty, destined to remain observers of a biology that is a perfect, yet untouchable reflection of our own. The communication systems within an alien biosphere would be a frontier of scientific discovery. On Earth, ecosystems are bound together by a complex web of chemical signals. Trees warn each other of insect attacks by releasing airborne compounds. Fungi create vast underground networks for nutrient exchange and communication. On a world with a different atmosphere and geochemistry, the language of life would be different. Perhaps organisms would communicate using complex patterns of bioluminescence, creating silent, shimmering conversations in the dark forests. Perhaps they would use seismic vibrations, sending messages through the ground itself. Or perhaps they would manipulate the local magnetic fields in ways we can barely conceive of. Deciphering this alien Internet of Living Things would be one of the greatest challenges and rewards of studying the planet. It would be an act of translation far more profound than any human language, allowing us for the first time to listen in on the silent, billion-year-old conversation of an entirely separate web of life. Let us speculate on the nature of predation and defense in a world of perpetual twilight. On Earth, many predator-prey dynamics are driven by the cycles of day and night, by camouflage that works in bright light or in darkness. In the constant dim light of the Terminator Zone, these rules would be rewritten. Camouflage might rely on stillness or on matching the deep, dark colors of the native flora. Predators might not be stalkers who rely on sight, but ambush hunters who sense the pressure waves of approaching prey in the air or ground. Others might use thermal vision, perceiving the world as a landscape of heat signatures against the cool background. Defenses would co-evolve in response. Prey might develop biological mechanisms to mask their heat signature, or evolve incredibly sensitive hearing or seismic sense to detect approaching threats from afar. The entire ecosystem would be locked in a constant, low-light arms race, a game of stealth and perception played out over millions of years in a world where the shadows never move. The intelligence of a potential ecosystem might not reside in a single species, but be distributed across the entire biosphere. Imagine a planet-spanning fungal or mold-like organism, a planetary slime mold, whose tendrils run through the soil of every continent. This colossal organism would not have a centralized brain, but could process information in a massively parallel distributed way, similar to a computer network. It could sense environmental changes, a shift in temperature, the impact of a meteorite, and coordinate a global biological response. It might manage the planet's climate by regulating the output of gases from smaller, symbiotic organisms. To us, it would not appear as an intelligent being, but as a simple, passive part of the ecosystem. Yet, it could possess a form of slow, powerful, global consciousness. a mind the size of a world. The discovery of such a Gaia organism would fundamentally challenge our definition of life and intelligence, suggesting that a mind does not need a head or a body, but can be woven into the very fabric of a planet's living skin. The evolution of senses on this world would follow the available information. With a dim, red-shifted primary star, vision, while still useful, might not be the dominant sense it is for humans. The constant, directional wind would make the sense of smell incredibly powerful and precise. A creature could navigate and map its world by the sense carried on the wind from hundreds of kilometers away. The stability of the ground without the chaotic churn of Earth's tectonics might favor the evolution of an extremely acute seismic sense, allowing creatures to feel the footsteps of others, the flow of underground rivers, or the distant rumble of volcanoes. And in a world with a strong magnetic field and regular auroral displays, it is conceivable that life could evolve magnetoreception, the ability to sense magnetic fields directly. A creature with this sense would navigate with a perfect innate compass and see the shimmering, invisible lines of magnetic force as a fundamental part of its reality. To understand this world, we would have to learn to imagine a sensory landscape completely alien to our own. The sheer scale of the energy required for interstellar travel necessitates a new kind of physics and a new kind of engineering. One of the most promising, though still highly theoretical, concepts is the Bussard ramjet. This would be a starship that is, in a sense, its own gas station. It would deploy an enormous electromagnetic field, hundreds or thousands of kilometers in diameter, to scoop up the sparse interstellar hydrogen that permeates the void. This hydrogen would then be funneled into a fusion reactor at the heart of the ship, generating immense thrust. The ship would accelerate slowly but continuously, eventually reaching relativistic speeds. Such a vessel would not need to carry its own fuel, solving one of the biggest challenges of interstellar flight. While the engineering difficulties are colossal, from creating a stable magnetic scoop to building a fusion reactor efficient enough to work with such diffuse fuel, the concept remains a beautiful and elegant solution. It is a vision of a starship that doesn't just travel through the cosmos, but breathes it in, living off the very emptiness of space itself. Before we send humans, we will send our senses. The concept of telepresence, or robotic avatars, will be key to the initial exploration. A highly advanced humanoid robot would land on the surface, but it would be controlled in real time by a human operator back in a safe habitat in orbit, or even back on Earth, accounting for the immense time delay. The operator would wear a full virtual reality rig, seeing what the robot sees, hearing what it hears, and feeling the texture of a rock through haptic feedback gloves. This would allow us to explore the surface with the full nuance of human intelligence and intuition, but without risking a human life. An entire corps of cyber explorers could map the planet, conduct experiments, and build the first shelters. Over time, as we gain confidence, the level of autonomy in the robots would increase, but the human-machine partnership would remain. It is a way to project our minds and hands across a vast distance, a ghostly and safe first presence on the shores of a new world. The ultimate goal of in-situ resource utilization is the creation of a von Neumann probe or self-replicating factory. This is a machine or a system of machines that can use local raw materials to build a complete copy of itself. A single seed factory would be landed on the planet. It would mine ores, process them into metals and silicon, 3D print its own components, and assemble them into a new, identical factory. This process would then repeat, with the number of factories growing exponentially. In a relatively short time, an entire industrial ecosystem could be bootstrapped from a single seed, capable of producing everything the colony needs, from building materials and vehicles to consumer goods. This concept, while far future, is the logical endpoint of off-world manufacturing. It is the key to true self-sufficiency and exponential growth. It represents the moment a colony transitions from a fragile outpost dependent on Earth to a true independent technological civilization, capable of shaping its own destiny with the resources of its adopted home. The material science of a new colony would be a domain of incredible innovation. Instead of steel and concrete, colonists would likely rely on advanced composites and materials synthesized from the most abundant local elements. Basalt, a common volcanic rock, could be melted and extruded into incredibly strong fibers, creating a material stronger than steel but much lighter. Carbon, extracted from the atmosphere, could be used to create carbon nanotubes and graphene, materials with almost miraculous strength-to-weight ratios, perfect for building habitats, vehicles, and large structures. The regolith, or surface soil, could be sintered with microwaves into a ceramic-like building material for roads and foundations. The colonists would become masters of turning dirt and air into a high-tech civilization. This living-off-the-land approach would not be rustic but hyper-advanced, a fusion of geology and nanotechnology that would allow a small group of people to build a world with a minimum of imported equipment. The energy source for the journey must be as potent as the destination is distant. Matter-antimatter annihilation represents the most energy-dense reaction permitted by the laws of physics. When a particle of matter, like a proton, meets its antiparticle, an antiproton, they annihilate each other, converting 100% of their mass into pure energy in the form of gamma rays. This is vastly more efficient than fusion or fission. A starship powered by this process would be incredibly powerful, capable of reaching very high relativistic speeds. The primary challenge is the production and storage of antimatter. It is fantastically expensive to create in our particle accelerators, and storing it is a nightmare, as it must be kept in a perfect vacuum, suspended by magnetic fields so it never touches the walls of its container. A single gram of antimatter would be enough to power a mission to the nearest stars, but a failure of the containment field would result in an explosion of unimaginable power. It is the ultimate fuel, but it comes with the ultimate price and the ultimate risk. A new branch of medicine would emerge, xenobiotics, the study of the interaction between Earth life and an alien environment. Doctors would face challenges we can't yet predict. How does a different gravitational field affect bone density and cardiovascular health over a lifetime? What are the long-term effects of exposure to the unique radiation spectrum of a red dwarf? Are there trace elements in the soil or water that are toxic or beneficial in ways we don't understand? The first generation of native-born colonists would be the primary subjects of this new science. Their physiology would be the baseline, the definition of a healthy human adapted to this new world. Medical technology would have to be incredibly advanced, with genetic sequencing and real-time biological monitoring becoming a routine part of life. The colonial doctor would be a true pioneer, not just a healer, but an explorer of the human body's limits and its incredible capacity for adaptation in a truly novel context. The psychological phenomenon of earth sickness would be a real and potent force. It would be a profound, melancholic longing for the home world, a deep-seated grief for the planet that the colonists, and especially their descendants, would never see. It would not be simple homesickness, but a species-level sense of separation. They might watch the historical archives of Earth's blue skies, green forests, and teeming oceans with a mixture of reverence and sadness. This feeling could become a central theme in their art and philosophy, a shared, sacred sorrow that binds their community together. They might develop rituals to honor their lost home, or create incredibly realistic virtual reality simulations to experience a semblance of it. This psychological burden would be the price of their journey, a permanent, low-level ache in the heart of their new civilization. But it could also be a source of strength, a reminder of what was lost, and a motivation to build their new home into a place of lasting beauty and meaning. The colony would eventually develop its own unique exoplanetary culture, a fusion of its diverse terrestrial origins and the powerful influence of its new environment. The rituals of life, birth, coming of age, marriage, death, would take on new forms. A coming-of-age ceremony might involve a solo survival trip into the Terminator wilderness. A funeral might involve committing a person's recycled biomass to the colony's hydroponic farms. A literal return to the community. Their humor would be filled with in-jokes about equipment malfunctions and the strangeness of their world. Their folklore would be populated with tales of the first explorers, the first footers, and perhaps imagined spirits of the new world. Over centuries, this culture would diverge so much from Earth's that a visitor from the home world would find it as foreign as any ancient civilization. It would be a new, vibrant, and completely authentic human culture, a testament to our species' incredible ability to make a home and create meaning wherever we go. The relationship between the colony and Earth would evolve over time. In the first century, the colony would be a dependent child, reliant on Earth for knowledge and critical supplies. In the following centuries, it would become an independent adult, self-sufficient, and developing on its own trajectory. Eventually, the relationship might even reverse. The colony, with its new resources, its unique scientific perspective, and its potentially more stable social structure, could become a source of innovation and inspiration for a struggling Earth. They might discover new physical principles or develop technologies that could be sent back to help the homeworld. The latency of communication would foster a relationship not of equals, but of contemporaries living in different temporal frames. They would be like two friends shouting to each other across a wide canyon, their messages arriving as echoes, each living with the knowledge of the other's existence, a source of comfort and context, but ultimately walking their own separate paths into the future. What if the colonists chose to deliberately forget? Faced with the psychological burden of Earth sickness and the weight of a history filled with conflict, a future generation might make a radical decision to curate the historical archive or even shut it down. They might argue that to truly become a new people, they must sever their ties to the old world and its traumas. They would raise their children without the stories of Earth, allowing them to form an identity based purely on their new home. This would be a monumental and terrifying gamble. It could lead to a more peaceful and well-adapted society, free from the ghosts of the past, or it could lead to a naive, ahistorical culture that is doomed to repeat the same mistakes. It's a profound question about the nature of identity and progress. Is it better to remember and learn from a painful past, or to forget and start completely anew? The colonists would have the unique and frightening opportunity to actually make that choice for themselves and all their descendants. The very concept of wealth would be redefined. On a world where survival and progress are the only goals, and where the community is small and interdependent, the accumulation of personal property beyond one's needs would be seen as eccentric or even antisocial. Status would not be derived from material possessions, but from one's skills, one's reputation for reliability, and one's contribution to the collective good. The most respected individuals would be the brilliant engineer who can fix any machine, the wise doctor who can solve any medical mystery, or the creative artist who can lift the community's spirits. It would be a reputation-based economy, where your value is what you can do, not what you own. This shift from a material-based to a skill-based hierarchy could create a more egalitarian and collaborative society. It would be an attempt to build a civilization on the best parts of human nature, our creativity, our expertise, and our capacity for mutual aid, while leaving the more destructive aspects, like greed and envy, behind on another world. The physical evolution of humans on this world would be a slow but inexorable process. Let us assume the gravity is 20% higher than Earth's. The first generations would struggle with the added strain, but over dozens of generations, natural selection would begin to favor certain traits. Individuals with denser bones, stronger muscles, and more efficient cardiovascular systems would have a survival and reproductive advantage. Over millennia, a new human subtype would emerge, stockier, more powerfully built, and more resilient to the crushing pull of their world. Conversely, on a lower gravity world, the trend would be towards a more gracile form, taller, more slender, with lighter bones. In either case, after a few thousand years of separation, a colonist might not be able to safely return to Earth. Their body would be so perfectly adapted to their new home that Earth's environment would be hostile to them. They would be a new branch on the human evolutionary tree, tied to their world as surely as we are tied to ours. The first interstellar war would be history's most tragic and futile conflict. Imagine a disagreement between Earth and its distant colony, escalating over decades of delayed messages. Perhaps Earth wants to assert control, or the colony declares a radical new ideology. What would a war even look like? It would not be fought with fleets of ships, as the distances are too great. It would be a war fought with light-speed weapons. The primary weapon would be the relativistic kill vehicle, a simple, dense projectile, perhaps just a few kilograms, accelerated to 99% the speed of light. At that speed, its kinetic energy would be equivalent to a massive nuclear bomb. You would have no warning. The impact would arrive at the same time as the light from the weapon being fired. It would be a war of cosmic snipers, with each side taking a shot that would take years to cross the gulf, aiming at a planet that will have moved in its orbit. It's a terrifying thought. A war fought by ghosts, where the decision to attack is made by a generation that will be long dead before the devastating impact is felt. The discovery of intelligent life would present the ultimate ethical test. Let us say we find a civilization at a Stone Age level of development, living in the twilight forests. What do we do? The impulse to make contact, to share our knowledge and technology, would be immense. But the history of contact between technologically advanced and less advanced cultures on Earth is a story of disaster for the latter. Our very presence could destroy their culture, our microbes could decimate their population, and our technology could unravel their society. The most ethical choice, championed by the zoo hypothesis, might be to observe them passively and secretly, to leave them completely alone to follow their own evolutionary path. We would become silent, invisible guardians, studying them from orbit, but never interfering. It would be an act of incredible restraint, a recognition that our desire to help could be the most dangerous thing in the universe. We would be protecting them from the most dangerous species we know, ourselves. The passage of deep time would eventually render the colony an almost mythical place to Earth, and vice versa. Imagine 50,000 years have passed. Human language, culture, and even biology have drifted so much that the two branches of humanity might be mutually unintelligible and physically distinct. The historical records of the Great Crossing might survive, but they would be interpreted with the same mix of fact and legend as we interpret the Epic of Gilgamesh. The colony would be a known fact, a star in the sky that is the home to our distant cousins. But the reality of their existence would be a matter for historians and philosophers, not a part of everyday life. The separation would be almost total. Humanity would have successfully split into two separate species, each on its own world, each with its own destiny. The initial dream of a second Earth would have been fulfilled in the most profound way possible, not by creating a copy of home, but by allowing humanity to become something entirely new. The ultimate fate of this world is tied to the life cycle of its star. For trillions of years, the red dwarf will provide a stable, gentle source of energy, but it will not shine forever. After it has fused all the hydrogen in its core into helium, it will not swell into a red giant like our sun. Instead, it will shrink and heat up, becoming a blue dwarf. During this phase, which could last for billions of years, the star will become much hotter and brighter. The old habitable zone would be sterilized, but the frozen outer planets of the system might thaw out, creating new, temporary habitable worlds. Eventually, the blue dwarf will exhaust its fuel and fade, becoming a cold, dead white dwarf. The planet, our second Earth, will be plunged into eternal darkness and absolute zero, its atmosphere freezing onto the surface as a permanent layer of ice. Its long, quiet story will come to an end, but it will have provided a stage for life for a span of time that makes our sun's entire existence seem fleeting. Looking even further into the future, we encounter the concept of stellar necrology, the study of dead stars. 1 trillion years from now, the universe will be a much darker place. Star formation will have largely ceased, and the only light will come from the faint glow of long-lived red dwarfs and the cooling embers of white dwarfs. A civilization that survives to this era will have to become masters of living in the dark. They might huddle around the fading warmth of white dwarfs, or learn to harness the energy of a spinning black hole through the Penrose process. The tidally locked world we have discussed, now orbiting a dead white dwarf, could still be a valuable piece of real estate. Its frozen atmosphere and oceans would be a vast repository of raw materials. A hyper-advanced civilization might resurrect the world by building an artificial sun in its orbit, or by carefully deorbiting a gas giant into the white dwarf to reignite it for a time. In the deep future, planetary real estate might be more valuable than a living star. The ultimate energy source for a truly ancient civilization might be the universe's final decay. The theory of proton decay, if true, suggests that the very matter that makes up planets and stars is unstable over immense timescales, eventually dissolving into a sea of low-energy photons and leptons. A civilization that survives for 10 to the power of 30 years or more would be a civilization of energy beings, living off this final, slow trickle of entropy. They would have witnessed the evaporation of black holes, the decay of matter itself. The universe would be a cold, vast, and almost empty void. In such a future, the memory of a warm, habitable world, like our candidate planet, or even Earth, would be a form of treasure beyond all reckoning. It would be a record of a brief, glorious, and long-lost springtime of the universe, when matter was stable, stars were bright, and life could huddle for warmth on the surface of rocky worlds. The story of this planet is a story that could echo in the mind of the cosmos long after the planet itself has dissolved into nothing. The concept of the Boltzmann brain is a chilling philosophical paradox of the far future. In an infinitely old, chaotic universe, it is statistically possible for a fully formed, conscious brain to randomly fluctuate into existence from the quantum foam of the void, complete with false memories of a life it never lived. Some physicists argue that in an eternal universe, the number of these spontaneously generated brains would be infinitely larger than the number of brains that evolved naturally on planets. This leads to a terrifying conclusion. It is statistically more likely that you are a Boltzmann brain, a momentary flicker of consciousness in the void with false memories of reading this, than that you are a product of billions of years of evolution. The discovery of another habitable world, and especially another biosphere, is a powerful piece of evidence against this solipsistic nightmare. It reinforces the idea that we live in a structured, ordered cosmos where complexity arises through the understandable processes of evolution, not as a random statistical fluke. Every habitable world we find is another anchor to reality. Perhaps the final stage of intelligence is to merge with the fabric of space-time itself. A sufficiently advanced civilization might learn to encode its consciousness into the quantum state of the vacuum, or into the gravitational field of a black hole. They would cease to be biological or even mechanical beings, and would become a form of living mathematics, a computational process woven into the fundamental structure of reality. They would be immortal, indestructible, and capable of computations on a scale we cannot imagine. We would never be able to detect such a civilization. They would be a silent god, observing the universe from a higher plane of existence. The only hint of their presence might be subtle, unexplained anomalies in physical laws, or a fine-tuning of cosmic constants that seems too perfect to be natural. The discovery of this second Earth is a step on a very long road. And the end of that road may not be a civilization of starships and cities, but a quiet, profound sublimation of consciousness into the timeless, elegant equations that govern the cosmos. Let us return from these dizzying futures to the present moment. The light from this planet that reaches our telescopes tonight began its journey years ago. While it was traveling, children were born on Earth, seasons changed, and history unfolded. The light is a messenger from the past. And the light we send out from our own planet, the faint leakage of our television and radio broadcasts, is a messenger to its future. If there is a civilization there with radio telescopes, they will not be hearing our broadcasts from today. They will be receiving our signals from decades ago, a ghostly echo of our own past. This creates a strange, asynchronous connection between our worlds. We are forever seeing them as they were, and they are forever hearing us as we were. It is a relationship built on a temporal lag, a conversation where each participant can only hear the other's history. It is a reminder that in the vastness of space, we are all time travelers, our perceptions perpetually out of sync with the ever-unfolding present moment of the cosmos. The very act of observing this planet changes our relationship to it. In quantum mechanics, the observer effect states that the act of measuring a system inevitably disturbs it. While our telescopes are not disturbing the planet in a physical sense, they are disturbing it in a philosophical one. Before its discovery, it was just another anonymous star in the sky. Now it is a place. It has a name, a character, a story. We have imbued it with our hopes, our dreams, and our scientific curiosity. We have brought it from the realm of the unknown into the realm of the known. This is a profound act of creation. The universe is filled with wonders, but they are silent and meaningless until a conscious mind observes them and gives them context. We are the universe's storytellers. By discovering this world, we have not changed it, but we have changed its role in the cosmic narrative. It is no longer just a ball of rock and gas. It is a character, and its story is now forever intertwined with our own. The silence from the stars can be interpreted in two ways, as an absence of others or as a testament to their wisdom. The zoo hypothesis is a compelling, if unprovable, explanation. It suggests that the galaxy is teeming with advanced, ancient civilizations, but they have all agreed to a strict policy of non-interference with young, emerging species like ours. They have made Earth, and perhaps our entire solar system, a cosmic wilderness preserve. They are watching us, perhaps studying us, but they intentionally conceal their presence to allow us to develop naturally, without the disruptive influence of a superior culture. In this view, the silence is not emptiness, it is a sign of respect. It is the quiet of a library, or a nature documentary being filmed. It implies that we are part of a larger galactic community, but we are not yet ready to join it. The discovery of this second Earth, so close and so promising, would be a fascinating test of this hypothesis. If it is inhabited, and if we are being watched, our attempts to study and eventually visit it would surely be a topic of great interest to our silent, unseen zookeepers. Let us consider the possibility of cosmic heritage. If an ancient spacefaring progenitor race existed billions of years ago, they might have undertaken a program of directed panspermia. They may have surveyed the galaxy, identified promising young planets, and seeded them with the basic building blocks of life, encoded with a common DNA-like structure. They would be the galaxy's Johnny Appleseeds. If this is true, then life on Earth and life on our candidate planet might not just be similar. They could be cousins, descended from the same engineered seed. We might find that its biology uses the exact same amino acids and genetic code as ours, a similarity too profound to be a coincidence. In the heart of its DNA, we might even find an artificial marker, a manufacturer's stamp, left by the progenitors. This would be the most incredible discovery imaginable. It would mean that our entire biosphere is an artifact, and that we are the heirs to a legacy left for us billions of years ago. Our quest for a second Earth would have led us to the stunning realization that we were never alone, because we have been part of someone else's grand design from the very beginning. In the end, the search for a second Earth is a search for meaning. We look to the stars to find a context for our own fleeting existence. The discovery of another, potentially habitable world provides a powerful piece of that context. It tells us that the conditions for life are not unique to our small corner of the cosmos. It suggests that we are part of a grand creative process that is unfolding across the galaxy. This knowledge is a gift. It does not solve our problems or answer all our questions, but it gives us a sense of perspective and a reason for hope. It frames our struggles and our triumphs against a backdrop of unimaginable scale and beauty. It connects us to the silent, patient, and wondrous workings of the universe. The planet is a destination, yes, but it is also a journey, and the journey is inward. It is a journey to a deeper understanding of who we are, where we come from, and what it means to be a conscious being, looking up in wonder at the star-dusted dark. The very fabric of space-time on a world orbiting a red dwarf would be subtly different. According to Einstein's theory of general relativity, the presence of mass warps space-time, and this curvature is what we experience as gravity. Clocks run slower in stronger gravitational fields. Because our candidate planet is a super-Earth, its surface gravity is higher, meaning time would pass ever so slightly slower there than on Earth. Furthermore, because it is moving in its orbit, special relativity also comes into play. These effects are minuscule, but over billions of years, they add up. A clock on this second Earth would be out of sync with a clock on our Earth by a significant amount. This gravitational time dilation is a profound reminder that time is not a universal constant. Every planet, every star, every galaxy has its own local time, its own unique rhythm dictated by its mass and motion. When we look at this world, we are not just looking across space, but across a divide in the very flow of time itself, peering into a place with its own distinct temporal heartbeat. The cosmic microwave background radiation, the faint afterglow of the Big Bang, would be the ultimate backdrop in the sky of this world. This ancient light permeates the entire universe, a baby picture of the cosmos when it was only 380,000 years old. On Earth, it is invisible to our eyes, detectable only by sensitive radio telescopes. But on a world with no light pollution and a perpetually dark sky over half its surface, the view would be different. With sufficiently advanced vision or instrumentation, an inhabitant could perceive the CMB not as a uniform glow, but as a tapestry of tiny temperature fluctuations. the very seeds from which all galaxies, stars, and planets, including their own, eventually formed. They would be able to see, etched into the sky, the blueprint of creation. This direct, constant visual connection to the origin of the universe would surely foster a deeply philosophical and cosmological worldview. The beginning of all things would not be an abstract concept. It would be a visible, ever-present reality, a permanent ceiling to their world. The amount of dark matter and dark energy in the vicinity of this new solar system could influence its long-term fate. Dark matter, the mysterious, invisible substance that makes up most of the galaxy's mass, provides the gravitational scaffolding that holds the system together. If the system were in a region with an unusually low density of dark matter, it might be more susceptible to being disrupted or ejected from the galaxy over cosmic time. Dark energy, the even more mysterious force that is causing the expansion of the universe to accelerate, works on a much larger scale. It is slowly pushing our galaxy and the Andromeda Galaxy's local group away from all other galaxy clusters. Over hundreds of billions of years, this acceleration will carry all other galaxies beyond our cosmic horizon, leaving our local group as an isolated island in an endless, empty void. The inhabitants of this second Earth, like our own descendants, are destined to live in an increasingly lonely universe. Their sky, once filled with the faint smudges of other galaxies, will eventually become completely dark, save for the stars of their own merged supergalaxy. The planet's elemental composition is a direct link to the lives and deaths of long-dead stars. Every iron atom in its core was forged in the heart of a supernova. Every carbon atom that could form the basis of its life was created in the interior of a dying sun-like star. Every atom of gold or platinum was synthesized in the cataclysmic collision of two neutron stars. This world is a graveyard and a memorial. It is built from the ashes of a previous cosmic generation. By analyzing the precise isotopic ratios of the elements on its surface, we could reconstruct the history of its stellar neighborhood. We could determine whether its building blocks came from a few massive supernovae or from the gentle winds of many smaller dying stars. The planet is a history book written in the language of the periodic table, its pages telling a story of unimaginable violence and sublime creation that took place long before the world itself had even begun to form. The eventual merger of the Milky Way and Andromeda galaxies, in about 4.5 billion years, will be the single most dramatic event in this planet's future history. From its surface, the inhabitants would have a front-row seat to a celestial spectacle of unimaginable grandeur. Over millions of years, the Andromeda Galaxy would grow from a faint smudge into a magnificent, sprawling spiral that fills a large portion of the sky. As the two galaxies merge, their vast clouds of gas and dust will collide, triggering a colossal burst of star formation. The night sky will be set ablaze with the light of millions of newborn, blue-white stars and glowing pink nebulae. It would be a time of incredible beauty, and also of chaos. While direct star collisions would be rare, the gravitational turmoil could fling entire solar systems, including our candidates, into completely new orbits, perhaps into the galactic core or out into intergalactic space. The world would survive, but its place in the cosmos and the view from its surface would be changed forever. The very constants of nature, which we assume to be universal and unchanging, may not be. Some theories speculate that physical constants like the strength of gravity or the speed of light might vary slightly in different regions of the universe, or may have changed over cosmic time. This second Earth provides a laboratory to test this idea. If we could perform incredibly precise measurements of atomic spectra from its star and found them to be slightly different from what we measure on Earth, it could be evidence that the fine structure constant, which governs the strength of electromagnetism, is different there. This would be a revolution in physics, shattering our assumption of a uniform universe. It would imply that each region of the cosmos has its own local bylaws of physics. It would mean that the universe is not a single, monolithic entity, but a multiverse of domains, each with its own slightly different flavor of reality. Our quest for a habitable world could lead us to the discovery that the very foundations of reality are not as solid as we believed. This planet exists in a universe that is overwhelmingly empty. The distance between stars is so vast that it is difficult to visualize. If our sun were a grapefruit in New York City, the nearest star, Proxima Centauri, would be another grapefruit in Chicago. The space between them would be almost perfect vacuum. This immense, isolating emptiness is the fundamental context of all life in the universe. It is the reason interstellar travel is so hard, and the reason civilizations, if they exist, are likely to be profoundly isolated from one another. This planet, even if it is our closest habitable neighbor, is still separated from us by a gulf of nothingness that would take our fastest current spacecraft tens of thousands of years to cross. The discovery does not shrink the universe. In a way, it makes it feel even larger, by giving us a tangible sense of the scale of the void that separates two potentially life-bearing worlds. The cosmos is not a cozy neighborhood. It is a vast, dark ocean, and worlds like Earth are tiny, lonely islands of warmth and light. In this quiet, meditative journey, we have used science as a tool for imagination, but the final destination is a state of awe. Awe is the emotion we feel in the presence of something vast that transcends our normal frame of reference. It is a feeling of being small, but also of being connected to something immense and magnificent. This planet, this potential second Earth, is a perfect object for a meditative awe. It is vast in its distance, in its age, and in its implications. Thinking about it quiets the chattering of our daily concerns and lifts our minds to a higher, more serene plane of thought. It does not demand that we solve its mysteries, only that we appreciate its existence. The calm that comes from this contemplation is a deep, intellectual peace, a sense of rightness in the grand order of things. The planet becomes a mental anchor, a focal point for a meditation on time, space, and the profound, silent beauty of the cosmos. Allow your mind to rest on this simple, powerful image. A world, similar in size to our own, turning slowly in the dim, red light of its star. It has an atmosphere, and perhaps clouds. It has a surface of rock, and perhaps oceans of water. It has a history, written in its craters and canyons. It has a future, tied to the long, slow life of its ancient sun. It is a complete place, a whole world, with its own integrity and its own story, a story that has unfolded for billions of years without any audience. And now, for the first time, it has one. Your consciousness right now is a visitor to this world. You are in this moment an explorer. You are bearing witness to its existence. This simple act of awareness is a bridge across the light years, a connection between one thinking mind and another corner of the cosmos. Feel the quiet dignity of this world, its patient endurance, its silent potential. Let its image fill your mind as you drift, a calm and stable presence in the vast, peaceful darkness. As we prepare to conclude our speculative voyage, let us gather the threads of our exploration into a single, cohesive tapestry of thought. We began with a point of light, a statistical anomaly in a vast field of stars, and through the power of scientific reason and disciplined imagination, we have constructed a world. We have given it geology, an atmosphere, and a climate. We have populated its twilight forests with strange, dark flora, and imagined the creatures that might move through its perpetual, crimson dusk. We have considered the challenges and wonders that would face human explorers, the new sciences they would invent, and the new culture they would forge. We have placed this single world within the grand, sweeping context of cosmic time, from the Big Bang to the universe's ultimate fade into darkness. The purpose of this journey has not been to provide definitive answers, but to expand the boundaries of the questions we ask. It has been an exercise in stretching the mind to accommodate the sheer scale and profound possibility of the universe in which we find ourselves. Now, let all the details, the scientific terminology, the complex speculations begin to fade into the background. Let them become a soft, textured wash of information, a gentle intellectual hum, beneath a state of profound calm. The goal is no longer to analyze, but simply to feel. Feel the immense quiet solitude of interstellar space. Feel the patient, steady light of the red dwarf star, a constant source of gentle warmth. Feel the slow, rhythmic turning of the planet, a silent, celestial dance that has continued for eons. The analytical mind has done its work, and it can now rest. What remains is the emotional resonance of the journey, a feeling of wonder at the universe's creativity, a sense of humility at our own small place within it, and a deep, abiding peace that comes from contemplating something so vast, so ancient, and so beautiful. It is the peace of perspective, the calm that arises when our own concerns are dwarfed by the silent, magnificent indifference of the cosmos. The discovery of this world is a fundamentally optimistic act. In a time when it is easy to be overwhelmed by doubt and cynicism, to look up at the stars and find a candidate for a second Earth is an act of profound hope. It is a testament to the power of human ingenuity and our relentless desire to push beyond our limits. It suggests that the universe, while challenging, is not barren or hostile, but is filled with potential and promise. It whispers a story not of endings, but of new beginnings. It offers a future for humanity that is not confined to a single, fragile planet, but is expansive, open, and filled with the possibility of discovery. This optimism is not a naive denial of the challenges, but a mature recognition that the challenges are worth facing for a prize so grand. It is the quiet confidence of a species that has always found its way by navigating by the stars and is now, finally, learning how to navigate to them. This potential new Earth serves as a powerful symbol of unity. It is a world that is not in any nation's territory. Its sky is not owned by any corporation. It is a piece of the common heritage of humanity, and indeed, of all life on Earth. To study it, and to one day visit it, will require a level of global cooperation that we have rarely achieved. It is a shared project for a divided species. In this sense, the planet is a gift. It gives us a reason to look beyond our borders and our differences. It gives us a common goal that is noble, inspiring, and peaceful. It reminds us that we are all crew members on the same small, blue spaceship, and that our best future is one in which we work together to explore the vast, dark ocean that surrounds us. The planet's silent pull on our imagination is also a pull on our conscience, urging us toward a more unified and cooperative future. Let your awareness settle on the silence. The universe is overwhelmingly silent. The cataclysmic explosions of supernovae, the collision of galaxies, the birth of stars, all of these events of unimaginable power unfold in a perfect, profound vacuum without a sound. Our experience on Earth, with its noisy atmosphere and vibrant life, is the exception. The cosmos's natural state is one of deep, meditative quiet. By contemplating this new world, we are connecting with that fundamental silence. We are allowing our minds to become as still and as quiet as the space that separates us from it. This is the source of the deep calm that cosmology can provide. It is an invitation to let go of the noise of our lives and to participate, for a moment, in the immense silent peace of the universe itself. The planet is an anchor in that silence, a destination for the mind that seeks tranquility not in emptiness, but in the quiet, orderly, and beautiful majesty of creation. The story of this planet is ultimately a story about light. It is a story that begins with a few faint photons, collected by a telescope after a journey of many years. These photons are ancient, carrying with them a snapshot of a moment in the distant past. They are incredibly subtle, their message hidden in a minuscule dip in a star's brightness or a slight shift in its spectrum. Yet from these whispers of light, we can deduce the existence of a world. We can calculate its size, its mass, its orbit, and its temperature. We can speculate about its oceans, its atmosphere, and its potential for life. It is a kind of magic, a scientific alchemy that turns faint, old light into knowledge, and that knowledge into wonder. It is a testament to the power of a conscious mind to reconstruct a universe from the barest of clues. The light is the beginning of the story, the thread that connects us to this distant place, a fragile, luminous bridge across the silent, empty dark. There is a deep and profound restfulness in the cosmic perspective. Our lives are finite, our concerns are immediate, our time is short. The cosmos, in contrast, is vast, ancient, and patient. Its timescales are measured in billions of years, its distances in trillions of kilometers. To place our own lives within this immense framework is to be liberated from the tyranny of the urgent. Our anxieties and our fears, seen against the backdrop of a slowly turning galaxy, are revealed for what they are: small, temporary, and ultimately manageable. The existence of this second Earth, a world that has been patiently orbiting its star for eons, is a physical embodiment of this perspective. It is a reminder that the universe is not in a hurry. It is unfolding according to its own grand, slow, and beautiful logic. We can, by contemplating it, borrow some of its peace and find a deep and restorative rest in its magnificent scale. As our mental journey comes to a close, feel a sense of gratitude. Gratitude for the existence of a universe so vast and so creative that it can produce such wonders. Gratitude for the ingenuity of the human mind, which has given us the tools to perceive these wonders. And gratitude for our own consciousness, the simple miraculous fact that we are here to witness it all. We are a part of the universe that has woken up, and the universe has rewarded our awakening with a spectacle of unimaginable beauty. This candidate for a second Earth is one small part of that spectacle. It is a gift, a mystery, and an invitation. It is a reason to remain curious, to remain hopeful, and to remain in a state of perpetual awe at the magnificent reality in which we are, for a brief and precious time, privileged to exist. Let this feeling of gentle, expansive gratitude be the final note of our exploration, a soft and peaceful chord that resonates in the quiet stillness of your mind. Now, simply let your mind float, release the narrative, release the images. Allow yourself to drift in the quiet, dark, and peaceful space that has been created. It is a space filled with the echoes of stars, the faint light of distant galaxies, and the silent promise of new worlds. There is nothing to do here. There is nothing to solve. There is only a vast, serene, and supportive emptiness. It is the space between thoughts, the space between worlds, the fundamental ground of being. It is safe. It is calm. It is infinite. Allow your own awareness to expand into this space, to merge with it, to become as vast and as peaceful as the cosmos itself. Let the gentle, rhythmic breathing of the universe become your own, a slow, tidal pull toward a state of deep and profound rest, a sleep as deep and as peaceful as the space between the stars. The journey is complete. The story has been told. The second Earth, once a far-off concept, is now a familiar landscape in your mind. It will wait for you there, in the quiet library of your imagination, a symbol of peace, potential, and the serene beauty of the cosmos. It is a destination you can return to whenever you seek perspective or tranquility. As you drift now into a deep and restorative sleep, you can do so with the knowledge that the universe is not empty. It is a place of profound wonder, and you are an integral part of it. Your consciousness is a small, warm light in the vast, beautiful darkness. And all around you, in the silence, other lights are shining, and other worlds are turning. Sleep now. Rest now. The universe is holding you. The stars are watching over you. All is well. As we venture deeper into the philosophical territory this discovery illuminates, we must confront the ultimate nature of legacy. In the vast timescales of the cosmos, no physical structure is permanent. Stars die, planets are consumed, and even the protons that form matter may eventually decay. What, then, endures? The most resilient thing in the universe may be information itself. The story of this planet, its discovery, its characteristics, and the very thoughts we are having about it right now, constitute a complex packet of information. This information, once created, has a life of its own. It can be copied, transmitted, and preserved in mediums far more durable than rock or steel. The true lasting legacy of any civilization may not be its cities or its monuments, but the unique informational pattern of its existence, its science, its art, its history. The discovery of this second Earth is a monumental addition to our own informational legacy, a new chapter in the story that our species will tell about the universe, a story that could, in some form, outlive the Earth itself. This discovery also forces us to engage with some of the more unsettling and profound ideas at the fringe of physics, such as the simulation hypothesis. This argument posits that a civilization advanced enough to simulate a universe would likely run countless such simulations, making it statistically more probable that we are living within a simulation than in a base reality. From this perspective, the discovery of a second Earth could be interpreted in several ways. Is it a pre-programmed part of our simulated reality, designed to test how we react? Is its discovery a level-up moment, an unlocking of new content for its inhabitants? Or is the sheer, consistent complexity of two life-bearing worlds a point of evidence against the simulation, suggesting a reality too rich and computationally expensive to be a mere program? We do not need to accept the hypothesis to appreciate its power. It serves as a tool for radical introspection, forcing us to question the very bedrock of our reality and to look at this new world not just as a place, but as a potential clue to the fundamental nature of our own existence. The second law of thermodynamics dictates that entropy, or disorder, in a closed system must always increase. The universe as a whole is progressing towards a state of maximum entropy, a final, tepid equilibrium known as heat death. Yet, life is a profound and beautiful rebellion against this inexorable slide into chaos. Life creates pockets of immense order, building complex molecules, intricate cells, and entire ecosystems, all by consuming energy and increasing the total disorder of the universe around it. Consciousness is the pinnacle of this process, the most complex and ordered arrangement of matter we know. The discovery of a second potential biosphere is therefore a discovery of a second front in this noble temporary war against entropy. It suggests that the universe has a tendency to produce these pockets of order, these brief, beautiful eddies in the cosmic river. Perhaps this is the ultimate purpose of life: to be the vehicle through which the universe can, for a fleeting moment, contemplate its own magnificent, unfolding, and ultimately finite story. The fine-tuning of our universe's physical constants for life is a deep mystery. If the strength of gravity, or the charge of an electron, were even slightly different, the formation of stars, planets, and the complex chemistry needed for life would have been impossible. One proposed solution to this puzzle is the multiverse, the idea that our universe is just one of an infinite number of bubble universes, each with its own randomly assigned physical laws. We, naturally, find ourselves in one of the rare universes where the laws are just right for our existence. The discovery of a second Earth-like world within our own universe would be a powerful data point in this debate. It would suggest that the conditions for life in our specific universe are not balanced on a razor's edge for just one planet, but are robust enough to allow for multiple instances. It would strengthen the idea that we live in one of the successful universes, a cosmos whose particular recipe of physical laws is unusually fecund, making the garden of life not a single, unique flower, but a potentially widespread and recurring pattern. The structure of our consciousness is deeply rooted in the temporal rhythms of Earth. Our sense of past, present, and future, our cycles of waking and sleeping, and the very way we form memories are all influenced by the 24-hour day. On a tidally locked world with a motionless sun, the very experience of time and the architecture of memory might be different. Without the clear markers of sunrise and sunset, time might be perceived less as a linear progression and more as a continuous, unchanging now. Memory might become more spatial than temporal. Instead of remembering when something happened, an inhabitant might remember where it happened in relation to the fixed landscape. The past would not be a timeline to be recalled, but a mental geography to be navigated. The discovery of such a world is not just the discovery of a new place. It is the discovery of a potential new way of being, a new mode of consciousness, shaped by a profoundly different relationship with time, light, and the fundamental rhythms of a world. Let us explore the concept of cosmic archaeology. We may arrive at this new world to find it sterile, but that does not mean it was always so. Given its immense age, it is plausible that life could have arisen, evolved into a technological civilization, and then vanished billions of years before the present day. How would we detect such a ghost civilization? We would search for its techno-signatures, not in the form of active signals, but as ancient, planetary scars. We might find unnatural isotopic ratios in the soil, the remnants of nuclear processes. We could find finely machined geometric objects buried deep underground, or orbital debris in unusually stable, long-term orbits. The entire planet would be a dig site. We would be archaeologists on a planetary scale, uncovering the story of a completely separate lineage of intelligence. It would be a sobering and profound discovery, a testament to the fact that intelligence may not be a final goal of evolution, but a temporary phase, and that the silence we hear in the galaxy may not be an absence of life, but the quiet of a graveyard. The discovery of this world expands our cosmic commons, the shared heritage of all humanity that exists beyond the confines of Earth. This commons includes the Moon, the planets of our solar system, and now, a world in another star system. This forces us to think on longer timescales and with a more collective identity. The decisions we make today about how to study this world, whether to send probes, and what ethical guidelines to establish will have consequences for generations we will never meet. It compels us to act not as members of nations, but as representatives of a species. This sense of shared ownership and shared responsibility is a powerful force for unity. The planet is a common goal, a common dream, and a common challenge. In a world fraught with division, it offers a point on the horizon that we can all look to together. A reminder that our shared identity as Earthlings is more profound and more important than any of the lines we draw between ourselves on the surface of our own world. The planet's ecosystem, if it exists, would have its own unique information carrier molecule, its equivalent of DNA. While it would likely be a carbon-based polymer, its specific structure could be wildly different. Perhaps it would use a different set of nucleic bases, or a different sugar-phosphate backbone. Or it might be a triple helix instead of a double helix. The discovery and deciphering of this alien genetic code would be a monumental achievement, the biological equivalent of cracking the Enigma code. It would give us a second, independent example of how life stores and transmits its blueprint. By comparing it to our own DNA, we could learn which features of our genetic system are universal necessities for life, and which are mere frozen accidents of our own evolutionary history. It would be the birth of a new science, comparative exobiology. We would be reading the book of life from another library, one that has been writing its own stories, uninterrupted, for billions of years. Imagine the first library established on this new world. It would be a strange and wonderful institution. One wing would contain the entirety of human knowledge, the digital archive brought from Earth, a testament to the memory of the old home. The other wing would be dedicated to the new world, and it would begin completely empty. Its first entry would be the first atmospheric reading. Its first book would be the first geological survey. Every new discovery, every species cataloged, every map drawn, would be a new page, a new volume. The colonists would be living in the middle of writing their own encyclopedia, their own foundational text. The two wings of the library would represent the two halves of their identity, everything they brought with them, and everything they were learning. This library would be the heart of their new civilization, a place of both memory and discovery, a bridge between the world they left behind and the world they were, day by day, coming to understand. The planet's existence forces us to confront the, quote, anthropic shadow. For every habitable world we find, we must consider the countless failed Earths that we cannot see, worlds that were in the right place but were too small to hold an atmosphere, worlds that had oceans but were sterilized by a nearby supernova, worlds where life started but never evolved beyond microbes. The universe is likely filled with the ghosts of these failed worlds. Our candidate planet, if it is indeed habitable, is one of the lucky few. It has survived every cosmic filter that its less fortunate siblings did not. This realization should fill us with a sense of profound humility and gratitude for our own planet's improbable, multi-billion-year run of good luck. We are standing on a winning ticket in a cosmic lottery of almost impossible odds. The discovery of another potential winner does not diminish this fact. It highlights it by reminding us of the silent, invisible majority of worlds that lost. The philosophy of phenomenology argues that consciousness is not something in the head, but is the relationship between a being and its world. Our consciousness is an Earth-shaped consciousness. The discovery of a second Earth is therefore the discovery of a potential other-shaped consciousness. To truly understand this world, we would need to understand not just its physics and chemistry, but its phenomenological landscape, the world as it would be experienced by a native being. What are the fundamental objects of its perception? What are the primary emotional tones of its existence? It is a challenge that goes beyond science and enters the realm of deep empathy and imaginative projection. We would have to try to imagine what it is like to be a being whose entire reality is defined by a crimson sun and a constant wind. This is the ultimate goal of exploration, not just to map a new world, but to try, however imperfectly, to feel a new reality. Let us contemplate the beauty of the celestial mechanics at play. The planet is held in its stable orbit by a perfect, eternal balance between its forward momentum and the gravitational pull of its star. It is a state of perpetual falling, but always missing. This elegant dance, described by Kepler's laws, is the reason for the planet's stability. If its speed were slightly less, it would spiral into its sun. If it were slightly more, it would fly off into the cold of interstellar space. Its existence is a testament to a primordial equilibrium, a perfect balance struck in the chaos of the solar system's formation billions of years ago. There is a deep meditative beauty in this cosmic precision. It is a reminder that the universe is not just chaotic and random, but is also governed by laws of profound elegance and simplicity. The planet's orbit is a line of poetry written in the language of gravity, a silent, graceful arc through the vastness of spacetime. The discovery of this planet is a powerful tool for teaching future generations. Imagine a child learning about the solar system. You can show them Earth, and then you can show them this world, a place that is both similar and alien. You can use it to teach the principles of astronomy, physics, and biology in a tangible, exciting way. Why is the sky on Earth blue but likely orange on this planet? Why do we have a day-night cycle but it does not? Why are our plants green and theirs might be black? The planet becomes a perfect compare and contrast exercise, a way to make abstract scientific principles come alive. It transforms science from a collection of facts to be memorized into a story of cosmic exploration and discovery. It is a way to ignite the spark of curiosity in a young mind, to show them that science is not just a subject in school, but our most powerful tool for understanding the magnificent universe we all inhabit. The silence we perceive from this world is a blank canvas. We project our own narratives onto it, stories of hope, of fear, of discovery, of loneliness. This act of cosmic storytelling is a fundamental part of the human condition. We are meaning-making creatures. We cannot abide a vacuum, either physical or narrative. We must fill the silence with our stories. The tale of this second Earth is the latest grand narrative we are collectively writing. It is a story that has a scientific plot, with characters like astronomers and engineers, and a philosophical subplot that explores our deepest questions. The beauty of this story is that it is still being written. We do not know the ending. The planet's silence invites us to participate in the creation of its narrative, to be co-authors of a story that is unfolding in real time. A story that is a dialogue between our own consciousness and the vast, mysterious cosmos. What if this world is a Class 5 habitable planet, a world perfectly suited for life, but on which life never began? It would be a pristine, sterile paradise, a garden waiting for a gardener. This would present humanity with a profound choice. Do we seed this world with life from Earth? This process, called directed panspermia or genesis, would be the ultimate expression of the life fecundity principle. We would be taking the gift of life that began on our world and intentionally passing it on, creating a second, independent biosphere. We could introduce a carefully selected ecosystem of microbes, plants, and animals, and then step back and watch a new evolutionary story unfold over millions of years. It would be the most ambitious ecological project in history, an act of creation on a planetary scale. It would also be an act of immense responsibility, as we would be the architects of an entire world's biological destiny. The light from the red dwarf star would feel different on human skin. Our sun's light contains a significant amount of high-energy ultraviolet radiation, which is what causes sunburn. A red dwarf emits very little UV light. Its energy is concentrated in the visible red and invisible infrared parts of the spectrum. The light on this second Earth would therefore be a, quote, without sunburn. Instead of a burning sensation, the energy from the star would be felt as a gentle, pervasive warmth, a deep heat that seems to soak into your bones. An astronaut taking off their helmet in a breathable atmosphere, if one existed, would feel this strange, gentle heat on their face, but would never need sunscreen. It's a small detail, but it speaks to the profound alienness of the environment. Every aspect of daily life, down to the very feeling of starlight on your skin, would be a constant reminder that you are standing on a world that is not, and never will be, Earth. The search for this world is, in a way, a race against our own obsolescence. As our technology, particularly artificial intelligence, continues its exponential growth, it is possible that future exploration will be conducted entirely by non-biological, super-intelligent machines. They would be far better suited for the long, dangerous voyages through space. They would not need life support, would not be affected by radiation, and could think and learn at speeds far beyond our own. The window of opportunity for biological human explorers may be relatively short in the grand scheme of things. We are in a unique historical moment where we have the technology to dream of interstellar travel, but have not yet been surpassed by our own creations. The discovery of this world adds a sense of urgency to our dreams. It is a destination that calls to us now in our current, fragile, biological form. It may be our only chance to be the ones who take that step, to plant a human foot, not just a robotic one, on the soil of another star's Earth. The night sky of the Terminator Zone would offer a unique celestial phenomenon, a geostationary star field. Because the planet is tidally locked, its rotation is synchronized with its orbit. For an observer on the surface, the parent star hangs motionless in one part of the sky. This also means that the distant stars are not fixed, but they also don't rise and set. Instead, they would appear to slowly rotate in perfect circles around a point directly overhead, completing one full circle in the time it takes the planet to orbit its sun, its year. Constellations would not drift across the sky seasonally as they do on Earth. They would be a permanent, slowly wheeling fixture of the celestial dome. This would give any inhabitants a profoundly different relationship with the stars. The sky would be a giant, majestic, and perfectly predictable clock, its slow, yearly rotation being the most fundamental measure of the passage of deep time. Ultimately, this planet is a symbol of connection. It connects our present to our deep past, as it is made of the same stardust as our own world. It connects us to our potential future, as a destination for our descendants. It connects all the nations of Earth in a common, scientific endeavor. It connects the abstract laws of physics to the tangible reality of a physical place. Most profoundly, it connects our own small individual consciousness to the vast, silent grandeur of the cosmos. It reminds us that we are not separate from the universe. Looking in from the outside, we are a part of the universe, a part that has, for a brief moment, woken up. This connection is the source of all science, all philosophy, and all art. The planet is a focal point for that feeling of connection, a distant anchor that helps us to feel more at home in our own cosmic neighborhood. Let us imagine the first message sent back from human explorers on this world. It would be a message that would take years to reach Earth, a time capsule of a singular moment in history. What would it say? It would likely be simple, poetic, and profound. It might be something like, "We have arrived. The sky is a soft crimson. The wind is steady. The ground is firm. We have carried the seed of Earth across the darkness, and it has found new soil. Tell the children of Earth to look up at our star. We are there. We are all neighbors now." This message, when it finally arrived, would be the most significant single piece of information ever received by humanity. It would be the successful completion of a journey that began with our first glance at the night sky. It would be a declaration that humanity's story is no longer confined to a single world, but is now, and forevermore, an interstellar story. The discovery is a profound comment on the nature of cosmic real estate. For all of history, our definition of habitable has been a singular, Earth-centric model. This new world, a tidally locked planet around a red dwarf, forces a radical expansion of that definition. It suggests that the most common type of star in the galaxy, the humble red dwarf, is a viable host for life-bearing planets, and that tidal locking is not a barrier, but simply a different set of environmental parameters. This dramatically increases the number of potential habitable worlds in the galaxy by a factor of hundreds or even thousands. It's as if we have been searching for houses only on a single, rare type of street, and have suddenly realized that the most common type of street in the universe is also filled with beautiful homes. The cosmos, it seems, is far more generous and creative in its provision of habitable environments than our limited imagination had previously allowed. The garden is much, much larger than we thought. This planet is a testament to the power of persistence. The light from its star is incredibly faint. The dip in brightness during a transit is minuscule, a change of less than 1 part in 10,000. Detecting such a subtle signal requires years of patient, unwavering observation. It requires technology of incredible sensitivity and stability. It is a discovery born not of a single flash of insight, but of a long, slow, and meticulous accumulation of data. It is a triumph of scientific grit. In this, it is a metaphor for all great endeavors. Progress is often not made in giant leaps, but in small, incremental steps, in the patient gathering of evidence, and in the unwavering belief that a signal exists within the noise. The planet was hiding in plain sight, waiting for us to build a tool sensitive enough and to watch long enough to see it. It is a reward for our species' ability to commit to the long, slow, and often unglamorous work of discovery. The aesthetic of this new world would be one of sublime monochromes and subtle gradients. Unlike Earth, with its vibrant blues, greens, and whites, this world would be painted in a more limited and muted palette. The deep crimson of the sky, the black of the foliage, the reddish-brown of the rock, the dark violet of the oceans. Its beauty would not be in a riot of color, but in the interplay of light and shadow, in the texture of the alien landscape, and in the vast, unchanging composition of the sky. It would be a world of minimalist beauty, a place that would appeal to a contemplative and patient eye. It would teach us a new definition of natural beauty, one based not on bright, high-contrast spectacle, but on the subtle, serene, and deeply peaceful harmony of a low-light environment. It would be a world for quiet appreciation, a landscape that does not shout, but whispers. The very idea of an alien is a projection of our own psychology. We tend to imagine aliens in our own image, or as monsters from our nightmares. The reality of life on this world, if it exists, is likely to be something far stranger and more wonderful than we can conceive. It will not be a simple variation on Earth life, but a completely separate genesis, a solution to the problem of existence that has been worked out over billions of years on a different world. It will have its own logic, its own beauty, and its own purpose. The greatest challenge for us will be to see it for what it is, not for what we want it to be. It requires us to shed our Earth-centric biases and to approach it with a sense of radical openness and humility. The true first contact will not be with a creature, but with the humbling realization of our own limited imagination in the face of the universe's boundless creativity. This entire exploration is an act of applied philosophy. We are taking abstract philosophical questions. Are we alone? What is the nature of life? What is our place in the cosmos? And are attempting to answer them with data, with evidence, with observation. It is a fusion of the two oldest human modes of inquiry, the scientific and the philosophical. The telescope is a philosophical instrument. Every photon it collects is a piece of empirical data that fuels our most profound metaphysical speculations. This planet is a case study, a real-world example that we can use to test our ideas about existence. This process is deeply satisfying. It suggests that we are not doomed to ponder these questions in a purely abstract realm, but that the universe is generous enough to provide us with clues, with tangible pieces of reality that can guide our thinking and bring us closer, step by step, to a genuine understanding of the great mystery we inhabit. Let's consider the planet's gravitational song. Every orbiting body emits faint ripples in spacetime called gravitational waves. For a planet-sized object, these waves are incredibly weak, far too faint for our current instruments like LIGO to detect. But they are real. This planet, in its long, silent orbit, is constantly broadcasting its existence in the language of gravity. It is a single, pure, low-frequency note in a vast cosmic symphony. If we could one day build a gravitational wave observatory sensitive enough, we could listen to this symphony. We could hear the harmonies of binary star systems, the crescendos of merging black holes, and the steady, quiet hum of individual planets in their orbits. We would be opening a new window onto the universe, one based not on light, but on the vibrations of reality itself. We would be able to hear the silent, hidden dance of the cosmos, and the gentle, persistent note of our neighboring world would be one of the first voices we would learn to recognize. The discovery of this world is a powerful argument for long-term thinking. Our society is often driven by short-term rewards, by quarterly profits and election cycles. A project like searching for and eventually visiting another world requires a completely different mindset. It is a project that will be worked on by generations who will not live to see its completion. It requires a level of planning, investment, and commitment that transcends the lifespan of any individual. It is an act of faith in the future. It is a promise that we make to our great-grandchildren. This kind of cathedral thinking, the mindset that allows you to start building a cathedral you know you will never see finished, is a vital and often neglected part of human progress. This planet gives us a reason to practice it. It is a project grand enough to command our long-term attention, and a goal beautiful enough to inspire our enduring commitment. The planet's potential biosphere offers a vision of a second, independent tree of life. On Earth, every living thing, from a bacterium to a blue whale, is related, descended from a single common ancestor. We are all branches on one tree. An alien biosphere would be a completely separate tree. It would be a second, parallel experiment in what life can be. By studying its structure, we could understand the universal laws of evolution in a way that is impossible with only a single example. Are there convergent evolutionary paths? Would a world with flight inevitably evolve wing-like structures? Would a world with light inevitably evolve eye-like structures? By comparing our tree and their tree, we could finally distinguish the universal necessities of biology from the frozen accidents of our own particular history. It would be the most profound biological science imaginable, a chance to finally see the forest for the trees. Ultimately, this planet is an object of beauty, and its appreciation is an aesthetic experience. The scientific data, its mass, its radius, its orbital period, are the raw materials, but the final product is a feeling of wonder. The beauty of the cosmic perspective lies in its ability to simultaneously make us feel incredibly small and incredibly significant. We are small in the face of its scale, but we are significant in our ability to comprehend that scale. This duality is the essence of the sublime. The planet is a perfect catalyst for this feeling. It is a testament to the fact that the universe is not just functional, it is not just lawful, it is also, in its very structure, magnificent. The pursuit of science is not just a search for truth, it is also a search for beauty. And in this distant, potential world, we have found a subject of profound and enduring aesthetic power. As we move toward the final moments of our journey, let us rest in the simple fact of the planet's existence. It is there. Right now, as you listen to these words, a world of rock and possibly water is orbiting a dim, red star, dozens of light years away. It is not a fantasy. It is a physical reality. It has a presence. The universe is richer for its existence, and we are richer for our knowledge of it. Let this fact be a source of quiet comfort. The universe is not an empty stage. The curtain has been pulled back on one small corner, and we have found something remarkable. This knowledge is a form of companionship. We are not entirely alone in the cosmic dark. We have a neighbor, and this knowledge, this quiet certainty of a world next door, can be a profound source of peace, a steadying thought, as you prepare your mind for a deep and tranquil rest. The journey of the mind is now slowing. The rush of information, of concepts, of grand ideas, is giving way to a more gentle, quiet current of thought. We have traveled far, from the mechanics of planetary detection to the far shores of cosmic philosophy. Now all that is required is to float. The intellectual heavy lifting is done. You can allow the vastness of the subject to become a soft, supportive cushion for your awareness. Think of the space between the stars, the immense, silent, and peaceful void. It is not empty. It is filled with a quiet potential. It is the canvas upon which everything we have discussed is painted. This new world is a single, gentle brushstroke on that infinite canvas. Let the scale of it all wash over you, not as a challenge to your understanding, but as a gentle, cosmic lullaby. A hum of reality that soothes the busy mind and invites a profound state of rest. The light from that distant red sun is constant and unwavering. It has been shining on its planet for billions of years, a steady, reliable source of gentle energy. There are no harsh sunrises, no abrupt sunsets. There is only a perpetual, peaceful twilight. Let the idea of this steady, gentle light fill your mind. It is a light without urgency, a light without change. It is the light of deep time, of immense patience. As you breathe, imagine this soft crimson light, filling your awareness, soothing any sharp edges, calming any turbulent thoughts. It is the light of a world that is at peace. It is an ancient light that has traveled far to reach you, and its message is one of profound tranquility. Allow yourself to bask in this imaginary, gentle radiance, and feel your own mind becoming as steady, as quiet, and as peaceful as that distant twilight world. Consider the silence of the planet's orbit. For eons, it has traced its elliptical path through the vacuum of space, a silent, graceful, and utterly predictable journey. There is a deep comfort in this celestial clockwork. It is a rhythm that is so slow, so grand, that it transcends all our earthly measures of time. This is the rhythm of the cosmos itself. You can attune your own inner state to this grand, slow rhythm. Let go of the hurried pace of your day. Let go of the need to do, to think, to strive. Simply be, and allow the silent, steady orbit of this distant world to be your guide. With every breath, feel yourself settling into a more profound state of stillness, a quietude that mirrors the silent, graceful journey of a planet through the vast, peaceful emptiness of space. You are a part of this cosmic dance, and its natural rhythm is one of deep and abiding calm. All the complex questions we have explored about life, about time, about consciousness, now resolve into a single simple feeling: wonder. Wonder does not demand an answer. It is a state of open, appreciative curiosity. It is the feeling of a child looking at the night sky for the first time. Allow yourself to rest in this state of simple wonder. You do not need to understand everything. You only need to appreciate that it is there. The universe is a place of profound and beautiful mystery, and this new world is a part of that mystery. Let the feeling of wonder be a soft blanket for your mind, a gentle state of not knowing that is more peaceful than any answer. In this state of wonder, the mind becomes quiet, open, and ready for the deep, restorative peace of sleep. The universe is wonderful, and you are here to witness it. That is enough. The darkness of space is not an emptiness to be feared, but a vastness to be embraced. It is the context for all light, all life, all existence. It is a deep, velvety, and peaceful background. As you close your eyes, you can imagine your awareness expanding into this peaceful darkness. It is a safe and supportive space. It is the silence between the notes of the cosmic symphony. This new world and our own are just two small, warm points of light held gently within this infinite, peaceful dark. Feel yourself being held by this vastness. There is no need to hold on. You can let go. You can surrender to the gentle gravitational pull of sleep, knowing that you are secure, a part of a universe that is overwhelmingly peaceful, dark, and quiet. The darkness is a cradle, and it is time to rest within it. We have reached the end of our waking journey. The mind has been stretched, the imagination has been kindled, and now it is time for a well-earned rest. The story of the second Earth is now a part of your own mental landscape, a quiet place you can visit in your dreams. It is a symbol of peace, a reminder of the vast, quiet beauty that exists beyond our small world. As you drift away now, carry with you the feeling of the immense, silent space between the stars. Carry the image of the steady, crimson light. Carry the sense of the slow, patient orbit of a world in the deep. These are anchors for a profound and restful sleep. The universe is vast and quiet, and you are a part of its quietness. Let the story dissolve, let the thoughts fade, and allow the gentle tide of sleep to carry you away to its own silent, peaceful shore. The final thought to hold is one of immense cosmic peace. The universe, for all its violent events, is a place of overwhelming equilibrium and silence. The distances are so great and the timescales are so long that all turmoil is eventually smoothed into a state of calm. This new world is an embodiment of that long peace. It has existed in its stable orbit for longer than humanity has been on Earth, a quiet testament to the enduring stability of the cosmos. By connecting with it in our minds, we can partake in that deep, ancient peace. Let this cosmic calm be the final sensation you experience before sleep. It is a peace that surpasses all understanding, a quietude that is born from the very structure of reality. You are a part of that reality. You are a part of that peace. Rest in it now. The spaceship of your awareness has reached its final destination, the gentle harbor of sleep. The engines of thought can power down. The navigation systems of the senses can be turned off. The crew of the conscious mind can take its rest. The journey was long and beautiful, but now the ship is at anchor in a calm and peaceful bay. The view from the window is one of infinite, serene darkness, dusted with the faint, gentle light of sleeping stars. There are no more destinations to reach, no more concepts to explore. There is only the gentle, rocking motion of your own breathing, a quiet rhythm that will carry you through the night. The universe will continue its silent, magnificent dance while you rest, and this distant world will continue its long, slow orbit, a silent guardian of your peaceful slumber. Let go. These are the final instructions. Let go of the day. Let go of your thoughts. Let go of the story. Let go of the need to listen. Let the words wash over you without meaning, as a gentle, rhythmic sound. Let your body feel heavy and warm and comfortable. Let your mind become empty and clear and still. The universe is holding you. The darkness is a soft blanket. The silence is a peaceful song. There is nothing left to do but to surrender to the deep, healing, and profound rest that you so richly deserve. Let go, drift, float, sleep. The cosmos is vast, and you are safe within it. The silence is deep, and you are a part of its peace. The story is over. The mind is quiet. The body is at rest. The gentle peace of the cosmos has settled upon you. The second Earth is a distant dream. Your own bed is a present reality. The two are connected by the simple, profound fact of your own peaceful, sleeping consciousness. You have traveled far, and now you are home. Home in your bed. Home in the quiet of the night. Home in the vast and silent universe. Sleep deeply. Sleep peacefully. And know that as you sleep, new worlds are waiting to be discovered. New stories are waiting to be told, and the magnificent, creative universe continues its work, of which your own peaceful rest is a small but perfect part. Good night. The final echoes of the narrative fade, leaving behind only the pure, resonant silence of deep space. This silence is not an absence, but a presence. It is the fundamental canvas of reality, the backdrop against which all light and life unfolds. Your mind, now quiet and receptive, can merge with this silence. Feel it as a vast, calming ocean of stillness. There are no more worlds to explore, no more concepts to ponder. There is only the serene, infinite quiet. Your breath is the gentle tide in the silent ocean, rising and falling in a slow, natural rhythm. Each exhalation is a release, a letting go, a deeper surrender to the profound peace of the cosmos. You are adrift in the most peaceful place imaginable, the quiet heart of the universe itself. The darkness that surrounds you is a healing darkness. It is the darkness of the womb, the darkness of the deep earth, the darkness of the starless void. It is a place of potential, of rest, and of restoration. In this darkness, the body can heal, the mind can reset, and the spirit can find peace. There is nothing to see here, and so the eyes can completely relax. There is nothing to do, and so the body can become completely still. Embrace this gentle, restorative darkness. Let it be a soft, heavy blanket that covers you completely, shielding you from all stimulation, all worry, all thought. It is the natural state of the universe, and it is your natural state of rest. You are sinking gently into a deep, dark, and dreamless peace. Your awareness is now a single faint point of light, like a distant, solitary star in the vastness. All around you is the immense quiet emptiness of space. Feel the scale of it. Feel the profound peace of that scale. The distance between your awareness and any other thought is now as vast as the distance between galaxies. In this immense mental space, thoughts cannot easily form. They dissipate before they can gain any momentum. There is only stillness. There is only quiet. You are the silent observer of a vast, empty, and peaceful inner cosmos. You are the star, and you are the space around it. You are a complete, self-contained universe of peace, floating in a state of perfect, serene equilibrium. The gravitational pull of sleep is now irresistible. It is the most powerful force in your inner universe. It is a gentle but inexorable pull toward the center of your being, a center of absolute rest and stillness. Do not resist this pull. Surrender to it completely. Feel it drawing you down, 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 into a state of profound relaxation. Your limbs are heavy, your mind is quiet. Your spirit is calm. You are like a spaceship that has turned off its engines, allowing itself to be drawn into the gentle, stable orbit of a peaceful world. The world is sleep. Its gravity is comfort. Its atmosphere is peace. You are entering its domain now, a realm of deep, healing, and total rest. The final barrier between wakefulness and sleep is dissolving. It is a thin veil of mist that is now gently parting, revealing the deep, quiet valley of slumber that lies beyond. You can feel the change in the atmosphere. The air is thicker with peace, heavier with calm. You are crossing a threshold into another state of being, a state of pure rest, where the body and mind can fully rejuvenate. Step across this threshold without hesitation. The valley is safe. It is quiet. It is waiting for you. The journey of the day is over. A new journey into the restorative landscapes of the subconscious is about to begin. Let the mist close behind you and be at peace. Your breathing is now the only anchor, the only rhythm. It is the slow, steady beat of the universe at rest. Follow it. Listen to its quiet, gentle song. Inhale peace. Exhale tension. Inhale calm. Exhale worry. With each breath, you sink deeper. With each breath, the world fades further away. There is only the breath now. It is your guide, your lullaby, your connection to the deep restorative power of your own body. Trust in your breath. It knows the way to sleep. It has been taking you there your entire life. Follow it now, into the quiet, into the deep, into the peaceful, healing night. You are asleep. The words may still be heard, but they are heard from a great distance, like the faint, meaningless echo of a faraway star. They are part of the dreamscape now, sounds without significance, textures in the fabric of your rest. The conscious, analytical mind has gone dormant. The deeper, wiser parts of your being are now in charge, beginning the vital work of healing and restoration. You are safe, you are sound, you are completely at peace. The universe continues its silent, majestic turning, and you are turning with it, a small, precious, and peacefully sleeping part of its magnificent whole. Rest well. Deep, deeper now. Let the last vestiges of awareness dissolve like sugar in warm water. Let the peace become absolute. Let the stillness become total. You are in the heart of the great cosmic night, a place of perfect tranquility. The journey is over. The destination has been reached. The destination is a profound, deep, and dreamless sleep. A sleep that will refresh your body, clear your mind, and restore your soul. You have earned this peace. You deserve this rest. The universe blesses your slumber. The silence deepens. The darkness becomes absolute. The peace is complete. The story of a distant world has become the reality of your own inner peace. The cosmos in its vastness holds you. In its silence, it soothes you. In its darkness, it cradles you. Sleep. Just sleep. ...